In 2006, a British mathematician, Clive Humby, said that data is the new oil. I think that's a very relevant comparison. You think about crude oil, once we pull it from the ground, it isn't worth much until it's refined. In the same way, raw data doesn't hold much value until we process it. That's our job as data engineers, to take the unrefined data and turn it into insights that people can actually use. I think data is growing at an incredibly fast pace. For example, Statistica tells us that Google processes around 20 petabytes of data across its systems, and that by the end of the year, global data creation is expected to hit a staggering 147 zettabytes. And I think if you're watching this video because you're thinking of changing careers or you're just starting your career, this is where you are striking oil, because at the moment, it still feels like we're in the birth of a new era with regards to data. And hopefully, this project will give you some insight into what the role of a data engineer does, the tools that we use, how to configure those tools, when to use tools, when not to use tools. So having said that, let's look at the architecture as an overview. Our data source will be an on-premises SQL server containing Stack Overflow data. We're going to take the 2010 cut of that data and we're going to ingest that into our on-premises SQL server. This is fairly common in the industry. Companies have data residing on their internal servers and are looking to migrate or begin utilizing the cloud to modernize their data infrastructure. In our case, we'll be moving this data into cloud to leverage the scalability and flexibility of all of the Azure services. To move the data into Azure, we'll use Data Factory, which is a powerful ETL tool, extract, transform, load, or extract, load, and transform tool. In this project, we'll be focusing and using it for the extract and load steps, bringing our data into Azure without performing any transformation at this stage. This approach simplifies the process and lets us handle data transformation later on in the pipeline rather than doing it up front. Storage is going to be handled by Datalake Gen 2, where ingested data will be stored in Azure Datalake, which acts as a kind of central repository for all types of data. So it could be structured, so that could be tables, semi-structured, that could be JSON data, or unstructured, so that could be binary files, image files, things like that. And the key benefit of using Data Lake is flexibility. You don't need to conform the data to existing structures or schemas up front. Instead, you can store the data in its raw format, such as files or blobs, and that makes it easier to work with different diverse data types and allows you to handle the transformation much later on in the process as and when you need it. To transform our data, we're going to be using Azure Databricks. Azure Databricks is an open source analytics platform built for big data. Azure Databricks recommends a multi-layered approach to building out a reliable single source of the truth through the medallion architecture. The medallion architecture consists of three distinct layers, and that's the bronze layer, which is the raw data directly ingested from source systems. This is left in its original unprocessed form. This layer serves as a historical record of the raw data. You've then got your silver layer, which takes the raw data from the bronze layer, applies some cleansing, transformations to conform the data just enough for ad hoc analytics and reporting. The structures in this layer typically follow kind of more third normal form patterns, making the data more organized and accessible. And then finally, you have the gold layer. And this is where we store more project specific. This is the highly refined data used for reporting, generating insights, uh, and taking actions on that data. And then in this layer, this is often more modeled on Kimball star schemas or Inman data marts, so that you can optimize performance for business intelligence tools for like Power BI, for example. So we're going to take the data from our bronze layer, apply some transformations to cleanse and transform that data, and then we're going to move it from our silver layer into our gold layer. Once we have our gold curated layer, we're going to build out a data warehouse. And this is going to be a logical data warehouse. And what do I mean by logical? It means that we're not going to be copying data into a SQL Server database, for example, in the cloud. We're going to be creating a logical layer. Imagine, for example, something like a view. So that would be a logical view of the data. And that's what we're going to be building in Azure Synapse Analytics. So we're going to take the gold layer and then we're going to build our data warehouse over our gold layer, which is going to be our kind of curated view of the world. From there, we're then going to turn our data into more actionable insights. And for that, we'll use Power BI. Power BI is Microsoft reporting tool. It's their business intelligence tool, and we'll connect our data warehouse or our Synapse Analytics data warehouse directly to Power BI, and then we'll create some interactive real-time reports and dashboards. Of course, we would miss and we would be bad data engineers if we didn't mention security and governance. And two the two main tools that we're going to be ensuring that our data pipelines are secure and robustly managed is going to be keyvault, and we are going to be using managed identity. Azure follows the principle of least privilege, meaning users and systems are only granted the minimum permissions necessary to perform their task. This approach minimizes the risk of unauthorized access and helps protect sensitive data. Key Vault we'll be using to secure our secrets, and in our case, that would be the password for our on-premises database. And then we'll be using identity management through Azure Entra ID, which is now the old Azure Active Directory. And we'll use proper and we'll ensure that we use proper authentication and access control to manage our resources, ensure that we do adhere to principle of least privilege. So to recap then, we're going to be using Azure Data Factory to ingest our data. We're going to be using Azure Databricks to transform the data into our curated layers. And then we're going to be using Azure Synapse Analytics to load that data. And then finally, we'll be using Power BI to report on to report our actionable insights. So let's start off by taking a look at what we're going to be doing during the build of this project. The first thing we need to do is set up our environment. I'm going to assume that you don't have an on-premises environment set up. If you do, that's great. And if this is your first data engineering video, then hopefully this will help you understand the various component parts that go into a project like this. So migrating data from on-premises to Azure. And obviously bear in mind that this is on-premises on my laptop. This isn't a hardened corporate environment where they have security personnel and firewalls and air gaps and the different environment setups. But hopefully, you should get a good feel for the types of things that you'll be doing in a large corporate environment. In terms of environment setup, it's just going to be installing things like SQL Server, Management Studio. There are a couple of requirements for the integrated runtime from Azure that we need to install. But for the most part, this is really just getting our on-premises database set up. Second point step is going to be Azure resource setup. We'll be using Azure Data Lake. We're going to be using Data Factory, Synapse Analytics, Databricks. As a data engineer, it's your job to go and set those resources up. In some environments, you might walk in and they already have an Azure estate. They'll have storage set up. They'll have the necessary security and things like that, and enter IDs. But it's good for you to understand what goes into those things. So if you're troubleshooting some problems, is it access? Have you set up the resource correctly? And we're going to obviously try and apply the principle of least privilege. We only want to give the absolute minimum access required to do our job for each resource. Second step is data ingestion, where we're moving our data from our on-premises database to our Azure, to our Azure storage using Azure Data Factory. Data transformation is going to be performed by Azure Databricks. So that's where we are going to move our data from our bronze layer to our silver layer, then finally to our gold curated layer. Our data load, that's going to be where we create our logical data warehouse in Synapse Analytics. Data reporting is Power BI. That's where we're going to leverage Power BI, connect that to our data warehouse, and start creating some reports and actionable insights. And then finally, we're going to test our end-to-end pipeline. This wouldn't be very good if we set this all up and we had to press buttons at each step to ensure something happened. What we're going to be doing here is ensuring that our pipeline, so that means our on-premises database into Azure Data Factory, into our storage, transformed from bronze, silver to gold, into our Synapse Analytics data warehouse, and then finally into Azure. We want to make sure that that works flawlessly from end to end without any interaction by us as the data engineers. And hopefully this will give you a good overview of the various different tools that we're going to be using, what life would be like in terms of data engineering, how to set these things up, and ensuring that you've got a solid end-to-end pipeline. Okay, so let's set up our environment. Our environment consists of an on-premises SQL Server, and that's going to be the source of our data. So let's go and download Microsoft SQL Server. Make sure that you go to Microsoft's website and not any other websites. And you can see that it says on here that you can try SQL Server on premises or in cloud. This is the one we want, but actually if you scroll down a little bit, if you select this one here, it's going to ask you to install to sign up for different things. So, but down here you can install SQL Server 2022 Developer Edition. Now this is fully featured, but it's free, and therefore it's a test database and non-production environment. So I've clicked that now, and it's going to download to my downloads. Now I've already opened mine. So once you open yours up, you'll get the SQL Server Developer Edition installation window. I'm going to click custom, and I'm going to install the media here and click install, and that's fine. So once that's started, it's going to boot up the installation center screen. I'm going to click installation and then new SQL Server standalone instance. Now, bear in mind that this is a demo project, and so we're not going to configure this server in any real way. Let's wait for that to run. Okay, great. So here you'll see that it's specified a free edition and it's developer. Click next. I accept the terms. Next. I'm going to install the setup files. I'm going to click next. Turn off the Azure extension for SQL Server for now. We're not going to be using that for now. Click next. Now, all we're really interested here is just the engine. Okay, we're not interested in anything else in here for now. If we need anything later on, we'll install it. But for now, we just need the database engine services. Click next. I'm going to select name instance. I'm going to call mine 2022. Click next. And that's all fine. Just leave that as a default. And here is where we're going to be setting up the security for the server configuration. It's going to ask you for your authentication mode. Windows authentication mode, that is exactly what it says on the tin. So you'll authenticate on SQL Server by Windows mode. We're actually going to be selecting mixed mode for our project, and that will become apparent once we start connecting to Azure Data Factory. So let me put in my ultra secure password. And just to bear in mind that again, this is a engineering project. It's not meant to be a rock solid bulletproof SQL Server. Click next, and we're then going to install everything. So just let that work for a minute and install the various things it needs to. The other thing we need to install is SQL Server Management Studio. SQL Server Management Studio. Download SQL Server Management Studio, and then click on Download SQL Server Management Studio. Now, I already have a copy of that downloaded, so I am going to open mine up. And as you can see, I've already installed mine. But if you open up yours, the version I'm running is 20.2. It's a simple install, and once that's installed, we'll take you through how to connect it to your database. That's running through nicely, so we'll just wait for that to finish. While that's installing, let's go ahead and get a copy of the Stackoverflow database, which is going to be our source of data. And we're going to get a copy of that from Brent Ozar. Brent Ozar, if you don't know who he is, he's a Microsoft SQL Server consultant. He's an MVP. He says here, I make SQL Server go faster. He's got some training courses, can help you understand a bit more about SQL Server and what goes on under the hood. I have no affiliation with Brent Ozar. I just use his database from time to time. In my original architecture overview, we did say that we would use SQL Server the 2013 cut, but now that I've looked at it, it expands out to about 50 gig, which is fine for purposes for what it's used for. But I think pulling that data into Azure Data Lake would take a little while. When I tested it, it took about an hour and a half to pull up all of the tables. Some of them are about 10, 15 gig once they're expanded. So I think we're going to use the 2010 version, which is 1 gig download, expands out to about 10 gig. So let's click on that and download it. That shouldn't take too long. I think the 10 gig was a bit extreme because you're constrained, because even though this is on premises and we're pulling it into Azure, and there would probably be unlimited bandwidth in Azure, my upload speed was probably about 10 meg, I think. So it was taking a little while to get up there. But this should be good enough. He says on here that if all you need is quick, easy, friendly database for demos and following code examples, that's all you probably need. And I think he's right. That's probably all we need. So go ahead and download that, and then we'll come back and get that added to our database. How's our installation going now? So that's working through nicely. And then I think for now, the last two bits we need is Power BI, Power BI download. And I think you can either get this directly from, oh yeah, we can get this from here. So you can get it from download, or I think you can get it from the Microsoft Store. So you click download, and then the version that I'm using is the x64 version. It is October, I believe. Power BI deploy monthly updates. So this is the October version that I've got here. And once that's got, we can install that. And then the last thing we need is the Microsoft Open JDK, which is Microsoft's build of the Java development kit. Now we need that to run some of the Azure services, namely Azure Data, the integration runtime that's going to allow us to connect directly to, it's going to allow us directly to connect to our on-premises database, which should be installed in a moment. Okay, I'll speed this video up and wait for it to install. Okay, great. So before we connect to our database, let's just make sure we have everything installed before we continue. So what we've got here, we've got a copy of our Stack Overflow. So hopefully you should have extracted that out now into its own folder. We've installed SQL Server Management Studio. We've installed our SQL Server, and let's install Power BI Desktop. So I think that should already be installed here. Okay, maybe it's not. No, it keeps moving to a different screen. Okay, so let's say next, next, next. I want to create a desktop version. Okay, so that's great. So we'll be coming to this later on in the project, but it's good just to have it installed so that it's ready to go when we need it. And then finally, the last piece of the puzzle is the Microsoft JDK. Now this is the Java development kit, and when we're connecting from our Azure Data Factory to our on-premises, there's some Java requirements that's needed in order to do that. So we're going to install this. And one thing I need to tell you about is the path. It's important that we update the path here. So you can see that when it comes to the installation, it's got a little X next to it. So we want to say, yes, we want to install that on the local drive. So what that's going to do is that's going to tell your computer where Java is installed. And so when we come to install our integrated runtime, which allows us to connect to our on-premises database from Azure, it's not going to have any trouble finding out where Java lives and how to access those files in order for it to run. Click Next and install. Okay, so while that's doing that, let's move over to SQL Server Management Studio and let's connect to our database. So if you start up SQL Server Management Studio, oh great, so Power BI is now installed. You can click Finish. Let's see where we are on the JDK side of it. Okay, uh, that's just working nicely. Perfect. So SQL Server Management Studio, this is what we're going to be using to connect to our on-premises database. Our server name is localhost and backslash and then our instance name. I opted for mixed mode on our installation, but for this purposes, I'm going to be using Windows authentication. So I'm going to click connect, and all being well, we should connect to our database, or our SQL Server at least. Now for databases, we actually don't have anything yet. So let's attach our database that we downloaded from Brent Oza. That's our Stack Overflow database. So we want to right click and hit attach. And it's looking for an MDF file, which is effectively the database. And once we go into here, you can see that there are some other databases in here. We're just going to copy this and go to our File Explorer, click a new window and head over to here. So what we want to do is we want to go back to our Stack Overflow database, and if you haven't already, extract it out, and then you should be given two files in here. So we want to copy those and paste them into here like that. Okay, that shouldn't take too long. And then if we refresh this, we should get our Stack Overflow 2010 database. Click OK, and then click OK. And hopefully we should see that our database has now been attached. And then if we click New Query, we select star from users. There we go. Let's see how many rows are in that table. Users, so 300,000, that's fine. Okay, great. So now that we've got our database attached, this is what we're going to be using to pull into our Azure Data Factory. So what we'll be doing is on the next step, we'll be setting up our Azure resources. So that's going to be our Databricks, Azure Data Factory, our key vaults, so that we can start to pull this data into Azure. Okay, let's get started and set up some Azure resources. So the first thing we need to do is log into Azure. So let's log in first. If this is your first time logging into Azure or you're setting up your account, if you don't have an account, you can just go to Azure login, Azure. If you go to the Microsoft Azure homepage, you can start for free. So they give you a month's worth of data, month's worth of credit. It's $150, I think, it's about £130 or £20. And it's ample for you to start using these resources. Although, from my understanding, if you're doing a light project, as long as you don't spool up crazy compute power, then generally speaking, it's a few pounds a month when you start spooling things up. So it's no problem at all. I think I used about £30 in the first month or so. Probably wasn't even that really. So if you're wondering how to get dark mode, here you go into settings and then appearance and startup, and you can change how things look. As you can see, I've got mine docked. I can see all the resources, and you can have it kind of set up like this as well if you like. But this is just kind of personal preference. Obviously, I've already got my account set up. So if I go back to home here, and I'll keep this out so you can kind of see what I'm doing. One thing to note is in Azure, there are a lot of resources. If you go to more resources here, you can see that these are all of the resources that Azure has. And so I implore you to try and understand some of the naming conventions that you'll be using in Azure. So for example, here it's on the Microsoft website, and I'll leave a link at the bottom. It's trying to help you understand the best way to name your resources. So you can see here that this one is the way they're recommending it is you've got resource type, workload, environment, region, and then instance. It's there's no kind of you don't have to follow this, but it's a good start. And then there's the abbreviations, and this is really helpful because, like I said, you've got all of these resources, and you can see here you've got tons and tons of resources, and all of them have different things. They're all related to different things. So, for example, let's say we're going to go and set up a storage account now. Well, you might think it might be SA, but actually they use ST, for example. And then let's say something like, let's find Databricks. So you've got Databricks Workspace or Databricks Warehouse, whatever you want to call it. But these two links are just very handy to kind of think about, well, what's a good naming convention? In our project, we are just going to name them kind of intuitively. We're not going to adhere to kind of any sort of naming convention, although where we can, we'll try and stick to the abbreviation. Okay, so great. So let's start setting up some resources. So I think it's good to first of all set up a resource group. There's a couple in here from previous, so let's get rid of these actually while we're here. So we can just go in here, delete this resource group. Doesn't need to be there for now. And then go to this one here. Let's delete this resource here. And then what we'll do is we'll create a brand new resource group. Now, resource group in Azure is hopefully intuitive as it sounds. It's a grouping of resources. So, for example, when we create all of our resources, so we're going to create some storage accounts and Databricks and data factories. We're going to set all these different services up. So what we need is we need to group them, and so this is where a resource group comes into it. So what we're going to do is create a new resource group, and I'm just going to call this resource group MRB. Actually, I'm just going to call it MRB. Now you notice that I'm able to put a dash in here, and what you'll find, generally speaking, is resources or information that's local. And what I mean by local is there isn't an endpoint. It doesn't have to be unique globally. Allows you to put dashes in. But for example, a storage account, well, a storage account can be accessed over the internet, and so therefore it it does need to be unique. It has to have a unique kind of domain name, if you like. So here, or well, endpoint rather than domain name. So we're just going to call this just for the essence of time. We're just going to call this resource MRB, and then we're going to put everything in UK South because I am in the UK, and that is what we're going to be using. So let's just do review and create, and then create. Okay. Now it doesn't take long for Azure resources. Some resources take longer than others to set up, but let's start going through these now. So I think one of the first things we need to do is we need to set up our resource for our storage account. So our storage account is where we're going to be storing our data. So if we do create here, this is our data lake. So we're going to store it in our RG and the storage account is going to be storage and MRB. Okay, that's enough. We don't need, oh, it's already taken. So we're going to say 001. And actually, if you look at the naming conventions here, Microsoft does say, instance, you do set them up because in some instances, you do need to have more than one here. And that's fine for us. So generally speaking, let's just leave everything for the default. But what's extremely important on this one is when you click next and you're going to advanced, we're going to enable hierarchy namespaces here. So hierarchical namespace, it says hierarchical namespace complemented by data lake storage Gen 2 endpoints enables files and directory semantics. accelerates big data, analytics workloads, and enables access control lists. What they're really saying here is you can set up containers or what we would know as folders in say Windows Explorer, for example. If you don't change, if previous to this, you would have to set up your files. The names would be, you would kind of have to virtually set up your naming or your hierarchy. So, for example, a file would be called it would be called it would be called home folder slash container one slash uh, report.txt. But in here, it really is a folder setup, if you like. So we're going to click, the rest of this is fine. So we're just going to click review and create. And then we're going to click create. Okay, so we'll wait for that to spool up. The other one we need to set up is our Azure Data Factory. So let's go ahead and set that up. That's important. We're going to be using that for our data ingestion. Again, we're going to be setting it up in here. Instance details is going to be Data Factory MRB. Okay, and again, we're going to call that into UK South. Okay. There isn't any other, there's no other configuration for this. So we're going to click review and create and then click create. Then the other part we're going to need is Azure Synapse Analytics. We're going to create that now. What's the abbreviation? Synapse. Azure Synapse Analytics Workers, Synapse W, go. Great. So we're going to go in here, create our Synapse workspace, and we're going to call that RGMRB, Synapse Synapse MRB. I'm going to say, yep, it's fine. Account name, we're going to say it's subscription one. That is our storage account because Synapse Analytics needs access to our data. Actually, let's, before we do that, let's go back. Let's go back. Okay, okay. So what we need to do, and I'll explain this in a second, let's go back to our storage account. And what we need to do is create our containers. So the containers, if you remember back to our architecture, these are our layers, if you like. So we're going to create our bronze layer, bronze, and we're going to create gold, let's say silver, and then we're going to create gold. Now, there are what you can do in here, the other way you could do this is you could have something like data, for example, and then underneath in your data you could have something, you could have a directory in here, and we could call this bronze, and then in here you can add a directory called gold, and then you could have another one called silver. Now that is fine. However, the problem with this is it doesn't give you that fine grained security. So for example, if we go back to our containers here, I can give individual access to certain developers or people, analysts, scientists. I can give them access, fine grained access to these different layers here. That one isn't so much true in terms of the folder structures in here. That's a that's not something it's really built for. So the best way to do this is to separate them out by different containers. So for example, I can go into a bronze here, and I can go into my access control, and then I can give access to certain people. I can go in and add assignments, and that just gives us just that extra layer of security and ability to keep people out. So for example, you don't want people, anyone being able to go in and start messing around with your bronze layer or your gold layer or your silver layer. You only want to give that to certain people. You'll have people who will be responsible for ETL. You'll have people who are responsible for potentially cleansing data. Might have people responsible for analyzing the gold layer. So you just need to bear that in mind in how you set this up. But for our purposes, we're going to set that up at a container level. So let me delete that one there, and that's fine. Now, the reason why I've had to come in and set this up is because our Azure Synapse Analytics data warehouse was asking, well, where do you want to source the data from? So what we're going to do is we've created that now here. And so what we're going to do is we're going to set up our Synapse Analytics warehouse, and we're going to tell it where it's going to get our data from. So our was called Synapse MLB, and then the account name is going to be, so it says select your data lake storage Gen 2. So we've got our data lake Gen 2 here, and what we're going to do is we're going to say we want to access the gold layer because that's going to be our warehouse. And then it says assign myself the storage blob data contributor role to the data lake storage Gen 2 account hierarchy to query it in the workspace. This is the same as me going in and telling Azure Data Lake how to access our storage account. So it's a nice convenient shortcut. So we're going to leave that ticked and we're going to say review and create. Okay, perfect. Let's do create. Okay, great. So the other part that we need is the key vault. So key vault is where we're going to store our secrets, and for this purposes, it's going to be our password for our on-prem user account. So we're going to create a key vault here, and we're going to call it that one, and then our name is going to be key vault MLB. We're going to store it. Oh, there we go. There we go. So we're going to store this in UK South. Excuse me, and I think that's it. Let's see, access configuration. Yep, so we want Azure role-based access control recommended. So that's what we're going to do. So we're going to click review and create, and then we will say create. Now, as I mentioned before, Azure works on uh, uh, principle of least privilege. And so what that means is we need to set up some security to allow things or Azure resources to access other resources. So once this key vault is set up, I'm going to show you what that means. So Azure Key Vault really is it allows us to store secrets that only us or the people who create these key vaults should be allowed to have access. So what we're going to do is we're going to try and create a password in here for our on-premises. Now, obviously, we don't have an account or anything. This is just a demo, but I just wanted to point something out. So you can see here it says the operation is not allowed by RBAC. If role assignments were recently changed, please wait several minutes for the roles. Okay, so it's already complaining, and we haven't even done anything yet. So I'm going to go and generate here. I'm going to say this is going to be our SQL Server on-prem password. The secret is going to be 123, and then I'm going to select create. Okay, and automatically it's going to say that you are unauthorized, right? We cannot do that. So what we need to do is we need to go up to our access control here, and then we need to add ourselves as a key vault secrets officer. Okay, so it says perform any action on secrets of a key vault except manage permissions only works for key vaults that use the Azure role-based access permissions model. So I'm going to select that one. I'm going to click next, and then it's going to ask me for the members. So I'm going to add myself to that. So that's going to be me, and I'm going to say select, and then I'm going to say review and assign. and that's it. Okay. Now, what I can do now is go back to my secrets, click generate, and it's going to say SQL on-prem password. It's going to be 123, and I'm going to, is it still working? Okay, let's see. This may not work as it may have been a bit quick off the hip. So let me do create. Great. So that's perfect. So that means that our setup's in place now. So that allows us to create those passwords. So I'm going to go ahead and delete this. Okay. And then the other thing we need to create is our Azure Databricks. And this is what's going to allow us to transform our data. So let me go into here and select create. And then our resource is going to be RGMRB, and then it's going to be Databricks warehouse MRB. And is it going to complain? No. And I think for this one, we're going to say that's fine, and we're going to say review and create, and then create. Okay, and then that will go off and create our Azure Databricks. Now, Azure Databricks takes a little while to spin up, so that's going to be a little while before that starts on. But for now, let's see what resources we've got. So we've got a Databricks warehouse, we've got a data factory, we've got keyvault, we have some storage, and we have our Synapse warehouse. So that should be it in terms of resources for now. There are some other setup that we need to do in terms of security. So that's giving access to our data factory, to our storage and things like that. However, we'll work through that as we work on the different resources. But for now, our resources are set up. So next we're going to dive into our data factory and start pulling our on-premises data. Okay, before we get to our data factory, we need to set up a login and user for our on-premises SQL Server database. In order for Data Factory to connect to our Stack Overflow on-premises database, we need to create some credentials. So let's create a new query, and then we're going to create a login called Michael with a password. And that's going to be our ultra secure password. Then we're going to create a user called Michael for login, Michael. Then adhering to principle of least privilege, we're going to grant, select, and execute only on schema DBO to Michael. And then we're going to give that a run. And that's our credential setup. So that's going to allow us to connect from Azure Data Factory to our on-premises database. Go back into our Azure resources, and we need to store that password in our key vault. So we're going to go back to our key vault here, and we're going to go down to secrets, and then we're going to go generate import, and we're going to call this SQL Server on-prem password. And then our secret is going to be this here. And this will allow Azure to access our on-prem. So we'll click create here, and that will allow our data factory to access our on-premises database. So let's go into our Azure Data Factory and launch the studio. Again, I'm in dark mode here. You can select dark mode, go into settings, and then click dark mode. It's not available in all of Azure resources, but it is in Data Factory. So there are different tabs here. You've got home, you've got author. So this is where you create pipelines. This is where you start to develop your data factory. monitoring. So this is where you can start to look at the pipelines. Excuse me. You can view what's run, when it run, what was debugged, things like that. And then you've got manage, and this is where you've got your linked services and your integration runtime. So linked services are services where you are uh, reaching out of the data factory to somewhere else in Azure. So, for example, we'll be creating link services to our medallion architecture, which is stored on Azure Datalake. But for now, we're going to create our integration runtime. So, what is an integration runtime? Well, it's a service that allows you to access different services outside of Data Factory. So this one is the auto resolve runtime. So this comes kind of inbuilt into Data Factory, and this is the service that that allows you to connect to data sources and external compute. So this is the one that we'll use to connect directly to our Azure storage solutions and the different other services. But what we want is a runtime to allow us, or an integration runtime to allow us to connect to our on-premises database. So we're going to say we want an Azure self-hosted. I'm going to click continue, and then we're going to say it's self-hosted, and then click continue again, and then we're going to call this self-hosted integration runtime. Click create. Now, this is the interesting bit. So there are two options to set this up here. So you can either express setup, and that contains everything we need in order for this to work, or you can do it manually. Now, if you were in a large corporate organization, you would generally set this up manually because you would probably auto rotate keys to keep it more secure. But for our purposes, I think we'll just click on the express setup for this computer. So what this is going to do is this is going to download the integration runtime and install it locally on our computer. So, and what this contains is effectively this plus the keys, and it's integrated into everything you have here. Now, bear in mind that this integration runtime is tightly coupled to this data factory here. So if, let's say, for example, you decide to set up a new data factory, then you would need to run this process again, but you would need to modify this installation. So you would either have to uninstall it or do a different kind of setup to ensure that it now links to this to this data factory. So I'm going to click here, Launch Express, and what it's going to do is it's going to download this file here, which you can see. I'm going to click this installation, and I'm going to let that kick off. Oops. And what it's going to do is it's going to download about a gig's worth of data, and then it's going to install it. So I'm going to fast forward the video to enable that to speed up, so we're not waiting for that to download. Now that our integration runtime has downloaded and installed, let's go back to our data factory and see if we can start pulling some data from our on-premises database. So let's go back to author, and then let's create a new pipeline. And here is where you can see the different parts of the pipeline. So if you imagine this is a bit like SSIS, where you've got components that you can pull into your area, and then you can start to transform data. So in our instance, we're going to use a copy data, and we are going to call this copy user table. Okay, and then in our source, this is where we're going to pull our data from. As you can see, there's nothing in here yet. We're going to click new. And then we're going to go right SQL Server. And on here, our data set is going to be user table. And then the link service is going to be our on-premises SQL Server. So that's SQL Server on-prem. Now the integration runtime, that is going to be our new one that we've just created, SHIR. So we're going to use that as our integration runtime. And this is where we're going to set up our SQL Server. So let's, it's asking for our server name here. So let's jump into SQL Server Management Studio. Now, of course, from Azure Data Factory perspective, it's going to run as if it's running on your local machine via the runtime here. So when we look at what our server name is, this is the exact server that it's going to be called at localhost, because that's effectively where it's running from. So if we go back into our link service, we're going to put the server name as that. The database name is going to be Stackoverflow 2013. So let's copy that, go back here. And this is where our keyvault comes into play now. So you can see that our authentication type, you've got SQL Server authentication, you've got Windows authentication, you've got managed identity. We're going to use SQL Server authentication. Our username is going to be Michael, because that's what we set up. And then in terms of our password, obviously we could hard code our password in here, but we wouldn't want to do that. What we want to do is use Azure Keyvault. So what we're going to find is that at the moment, like I said earlier, in terms of security, Azure Data Factory knows nothing about our key vault yet until we tell it. So let's go ahead here and click new, and then it's going to say, what would we like to call it? So we'll just call it Azure Key Vault. I'm going to go to subscription 1. Key Vault name is going to be Key Vault MRB001, and then the rest we're going to keep it as is. So we're going to say test connection, and it's going to be successful. Now, even though that's a successful connection, it does not mean that we are going to be able to see any secrets yet, because of the principle of least privilege. So I'm going to click create, and then what you're going to see is it's going to say it's failed, right? It cannot access our secrets. So if you can see here, it says invalid status code forbidden. So what we need to do is we need to go back into our key vault, and we need to allow our data factory to have access to our key vault. So we're going to go into our key vault here, and we're going to give it access control, and then we're going to say add role assignments. Okay. And then here we're going to say key vault, and we're going to say key vault secrets user. So it says read secrets context only works for key vaults that use Azure role-based access control. So we'll click next, and then we're going to say the managed identity is going to be our Azure Data Factory. So let's select Data Factory v2, because that's the managed identity. And then the one that we're interested in is our Data Factory MRB. So we're going to select, and then we'll click review and assign and review. So give that a couple of seconds to complete. So that should have completed now. And then what we'll do is we'll go back to our Azure Data Factory, and we're going to refresh this. And hopefully we should see our SQL Server on-prem password. So that's great. And so what we're going to do from here is test it to see if we can actually link to our server. I'm going to click the Trust Server Certificate, and then I'm going to click Test Connection. give that a second to connect to our machine. Great, so the connection was successful. So we're going to click create here. And that's going to give us our on-prem database. And then now it's going to say, okay, well, what do you want to pull in? And in this instance, we're going to pull in our users. Now, bear in mind, the reason why our on-prem and my login can access these tables is because we have given the necessary access to the DBO schema. If I had given it access to specific users table, then that's all I would be able to see here. Okay, but in this instance, we want everything. So we're going to, but for now, we're just going to pull in the user table. Click OK. Let that spool up a second. So that gives us access to our table. Now the sink, this is where we are going to copy our data to. So the sink is like the destination, if you like. Actually, before we go there, let's have a look. Let's see if we can preview this data. So let's have a quick preview. And let's see what the data looks like there. Great. So what we're saying here is that now we're actually pulling data from Azure Data Factory from our on-premises database in the users table. So that is great news. Let's close that off. And then what we need to do is we need to give this a destination. So what we need to do is give it a new sync data set. And the data set is going to be Azure Data Lake Gen 2, okay, because that's what we've set up. And then we click continue. Now, there are different file types that we can set up. One of the main file types that you will hear bounded around once you start getting into your Azure career is Parquet. It's a kind of columnar actually say that word columnar type file setup. So the data stored in columns rather than rows, and it's highly compressed and it's built for kind of big data. So we're going to use Parquet for now. Click continue, and then we're going to call this this is the user table. Okay, user table Parquet. Okay. And then the link service, we're going to create a new link service because right now we don't have any access to our data lake. So we're going to click new, and then here we're just going to call it, we're going to call this bronze user data. And the integration runtime, we're going to leave it as auto resolve integration runtime. And the reason for that is because this is the Azure integration runtime. This is what connects our data factory to other Azure services. Authentication, we are going to leave as is, and then we're going to select our subscription key, and then the storage access name is going to be our data lake here. Okay, and then we're going to click test connection, and it's going to be successful. So we're going to click create, and then down at the bottom here is going to say, where do you want to store this data? So what we're going to do is we're going to browse it, and we're going to say we want to store this in the bronze layer. Now notice that what I'm going to do is I'm going to click OK here, and that's without telling it a directory or a file name. And that's because Azure Data Factory is smart enough to know that it's going to store the data that comes in, and it's going to give it exactly the same name, except it's going to call it Parquet rather than anything else. So I'm going to click OK, and that's it. Now from here, what we're going to do is we are going to click debug, and then that's going to give us kind of an instant feedback of where we are. So let's click debug, and let's see where we are with that. Now, hopefully this should throw up the monitoring. You can do this in the monitoring tab here as well, but you can see it's queued right now. And then let's see what it's doing, what it's up to. Okay, so that's the different inputs. Okay, so we're just going to give that a second. So it says it's in progress, and hopefully it should start copying our data up. I think there's a couple of million rows in this table, so it might take a little second. Let's see what's in monitoring. Now there's two parts to monitoring. You've got triggered, so that's where a service is triggered, and they'll pop up in here. And then you've got debug, which is what we're working on right now. So we'll click on here. It's going to give us the same information. So details. Let's see what it's doing. Okay, here we go. So this is interesting. So right now it's in progress. It's hit our self-hosted integration runtime. Data read is 304.68 megabyte, and rows written is 2.46713, and it's currently in progress. So let's see. Here we go. Data written 42. Okay, so we'll give that a second to spool up. Great, here we are. So that was a success. So you can see down here it was successful, and then you've got your output here. It shows you the data read, data written, rows copied, etc. So what we can do now is let's head back over to our data lake and see what we can see in our container. So we go into our bronze container, and here we go. This is our table. So this is the data that we have pulled from our on-premises SQL Server into Azure and stored it in our bronze layer. Now that we've been able to copy over a single table, let's head back into Data Factory and create a new pipeline to copy all of the tables from our on-premises database to our bronze layer. So let's click pipeline, new pipeline, and let's say copy all tables. And the activity we're going to be using is the lookup activity. And the lookup activity allows you to dynamically determine which objects that we're going to be working on. So what does that mean in reality? Well, let's head back into SQL Server Management Studio and let's create a new query. As you can see that the Stack Overflow database has a few different tables that we need to copy up. So we need to be able to tell Data Factory about those. And the way we can do that is if we do select star from sys.tables table in a join to sys.schemas schema on table.schema ID equals schema.schema ID, where schema.name equals DBL. And that's going to give us a list of the tables that we're interested in copying up into Azure. And you might be wondering, well, that query is a bit heavy considering all the tables already sit in DBL. Why are we querying the schemas table? Because if you run them both, you're absolutely right, they are. I guess the reason I'm showing you that is because if you walk into any organization, they have a whole host of different schemas. You'll have security schemas and audit schemas and account schemas and customer schemas. And you may not be interested in all of those separate schemas. You might just be interested in one of them or a few of them. But for our purposes, this is just to show you that you can separate the data out by different schemas and things like that. So let's be good citizens and let's remove the star and say select schema name as schema name and table.name as table name. Okay, so that's our query, and that's what we're going to provide to our lookup activity so that it can pulling all these tables into our bronze layer. Let's head back over into Azure Data Factory and set up our lookup activity. So this is going to be lookup all tables. And we're going to head into the settings. Now, in settings, it's asking for a source data set. Now, these two are no good for us because they're looking at specific tables. So we're going to create a brand new one. And we're going to say we need a SQL Server. And we're going to call this all tables. And the link service is going to be our on-premises database, our on-premises SQL Server. And we're going to connect via the integration runtime. Now that's already set up for us. And you can see that I do have the ability to select a table here, but I'm not going to because we need to dynamically inject our tables into this data set. So we're going to click OK. And you can see here that there are a number of different types of user query. So you can use a table or you can use a query or store procedure. And what we could do is we could copy and paste our query directly in here. So we could say something like that. And that would be great. That would work perfectly fine. Having said that, I prefer to have a level of abstraction in on our Azure Data Factory so that if it changes or we need to update it, because sometimes we need to change things and you don't always want to go into your pipelines to change it. So let's remove that for now and let's go back into our management studio, and I'm going to wrap this in a procedure, in a store procedure. I'm going to call this get all schema tables as begin and end, and then I'm going to indent that, and I'm going to say create. Okay, and the reason for that is, like I said, to just give us a level of abstraction. I could have done this in a view, but if I did this in a view, I'm still kind of saying select star from, and that doesn't give me warm fuzzy feeling. So, but what we can do now is going to store procedures, and it should be available. There we go. The other great thing about this is you can inject parameters. So if I wanted to add a schema parameter here, I could, and you could then dynamically change that here. The other important thing you need to look out for is this first row only. And as you start to work through Azure Data Factory, this will probably catch you out at some point. You'll run this pipeline and realize, well, where's all my data? Why haven't we pulled back everything? So let's switch that off and let's run this and see what we get. As you can see, there's two ways to run this. You've got add trigger and you've got debug. If you do it via trigger, then you need to click into monitor in order to look at it. If you click debug, then the output pops up immediately. So let's click debug. And this should only take a few seconds to run. It's queued at the moment. Okay, in progress. And let's see what it's doing. So it's going to run our get all schema table store proc, and hopefully this should have run now. Okay, great. Now, what this lookup activity does is it generates a JSON payload. So if I click on the output here, you can see that the title of this is output, but that's actually the name of the payload. And within that payload, you've got a number of different parts to it. So you've got count, and then you've got value, and underneath value, you've got the tables. Now, bear these in mind while I take you through the rest of this, because you're going to see in a second why this is important. So you've got output, you've got count, and you've got value. So bear that in mind, and I'm going to close it off now, and then we're going to think about, okay, now we have this data, and what we're going to do with it. Well, the next activity we're going to use is a for each. And we're looking at this for each because we we want to be able to copy all of these tables and on a dynamic basis. And that's why we're going to use this for each. So we're going to call this for each table. Okay. And in the settings, it's going to say what are the items that we're going to look at. So we're going to connect our lookup activity to our for each here. And upon its success, and this connector is going to then allow our for each to look at the data that's been pulled into our lookup activity here. So if I go into here, you can see that Azure Data Factory gives me the option to add dynamic content. If I click on this, it's going to give us three options here. Now, if I click on look up all tables, you're going to see that it's going to say the activity look up all tables has a payload called output. And if you remember back to a few seconds ago, that was the name of the payload that we saw in our lookup activity. And if I look up all tables count, this is the count that you saw in there, which had 9 in it. So that's going to be all look up all tables output, and then it's going to give us the value of the count. And then if we look at the value, this is the array of tables, and you can see it's an array of row data. And this is what we're interested in, because this is what we need to really inject from our lookup activity into our for each. Okay, so click OK. And that's it for the for each in terms of that part. But what we need to do is we need to enable it to copy each of the tables. So we go back to our copy user table here. What we really need is something like this, but we need to make this the source data a bit more dynamic so that it can copy all of the tables, not just the user table. So if we go back and we add a copy data activity, oops, didn't register that, and we're going to call this copy table. Now in the source, we're going to say all tables, because we're interested in the ability to select all tables, but what we need to do is we need to constrain it down to a specific table. So if we select the query here, what we need to be able to do is generate some dynamic content which will allow us to pull only the table that we're running for in that instance. So if I select add dynamic content, what we're interested in is we're interested in saying select the table that we're currently running for. So what does that look like? Well, we need to build a concatenation statement. So we're going to say concat, and then we're going to say select star from, and then what we're going to do here is we're going to say item dot schema name, and then we're going to give it a dot, and then we're going to say item dot table name, like that. Okay, and what that's going to enable us, that's going to really say select star from dbo dot and then the table name that it's injected. Okay, so we're going to select OK on that part, and that's going to give us our copy of the tables. And then what we need to do is we need to be able to store that data in our data lake. So what we're going to do is we're going to go into our sync, and we're going to say none of these are really useful because we need a specific dynamically set up Parquet data set. So we're going to say new, I'm going to call it Parquet. I'm going to say we need Azure Data Lake Gen 2, connect the Parquet format, and we're going to call this Parquet table. And the link service is going to be our bronze user data. So that's what we've set up. Now, This is the important bit, because what we're going to do is we're going to select the bronze folder, but we're not going to give it any other parameters. We're going to generate those. So we don't have a directory yet, and we don't have a file name. So we're going to click OK. Now we need a way to be able to tell the bronze layer, or the parquet table, where it's going to be stored, what the setup's going to be. So the folder name, for example. So what I'm going to do is select open on here. And this might be a bit unintuitive, but what we're going to do is we're going to give our parquet table a couple of parameters. So we're going to call it schema name, and we're going to call it table name. Okay, because what we need to be able to do is we need to be able to inject our our schema name and our table into this data, or into our parquet table here. So right now we've got the file path is bronze and then /, and what we need to do is we want to be able to say in here the directory is going to be our schema. So that's going to be our directory. So that would be bronze and then DBO. And in our file name, what we're going to do is we're going to build this out. So this will be in cat, and we're going to say we want to store it in the table name. Okay. And then we're going to say table name. So it's going to be something like users. And then after that, we're going to say, we're going to give it a the actual table name itself. So then we're going to say, we're going to concatenate it with table name and then dot parquet. So what would that look like? Well, that would look like something like bronze and then DBO and then users, and then it would be use, and then it would be and then it would be users dot parquet, like that. Now, why are we separating them out like this? Why are we putting the table underneath a folder called users? Well, that will become a bit more apparent as we move into Databricks, because we want to be able to store we want to modify this this date, or these tables in our gold layer to be in the Delta format, and it'll become apparent once we move it. But for now, this is how we're going to store it. So we're going to click OK on here. And then what we need to do is we need to be able to we need to inject our values from our for each into here. So let's go back to our copy tables. And as you can see that we've got two parameters here. And that's why it seems a little bit intuitive, because you're going into our parquet to add the parameters and then injecting them from here. But actually, if it was set up like this already, then it does make sense, because we're saying that the parquet table requires two parameters. It needs a schema and a table. So our schema is, we're going to give it some dynamic content, and this is going to be we're going to give this the item dot, and then we're going to call this a schema name, and then in here we're going to give it the table name, which is going to be item dot table name. Okay, just like that. And that's really it for now. So what we're going to do now is we're going to run this and see if it successfully copies over the tables. And the way we're going to do that is we're going to hit debug. Now let's see what happens. So that's going to start kicking this off, and the first thing it's going to do is run our our lookup activity here, which is queued right now. And once that's running, then it will start to kick off all of the for eaches on the tables. So we should get, okay, great. So it is moving. So you can see that this is a for each, but the for each is really running in parallel now. So it's going to try and copy these tables in. So you can see it looks like it's copied a few of those tables. So let's head over to our bronze layer and see what the data looks like. So let's refresh this. Okay, so we've got it in our schema and we've got, let's say, posts. Okay, great. So it looks like we're pulling this data correctly through. Going to bronze and then DBO. Great. Okay, so it's pulling this data. Okay, perfect. So let's refresh this. Okay, let's see. Okay, so while this is running, you can see that there are these glasses next to each of these activities. So if you click on one that's completed, you can see that it tells you the activity that it performs. So this one, data read was 3.8 meg, and the rows read was 161,000, and then the actual data written is 2.8. And because bear in mind that we're writing this to Parquet, so the data written is going to be less than the data read because Parquet's a compressed, or it's highly efficient storage. And then the number of rows written is the same amount of rows, and it tells you the time it took. And then if we look at something like that's in progress, so this one's been running for 1 minute here. Let's see. So this is 10 million rows. So there's a bit more data to it, but that shouldn't take too long. Hopefully, running at 2.99 here. Is this one finished now? No. So, yeah, so it's still running. So that's fine. Let's see what else we've got here. This one is So this one is 3 million, 1.269 gigs. Okay, that's great. That's fine. Okay, so we're going to let that run for a bit and pull that data into our Azure storage, into our bronze layer, and then we'll be back to start looking at Databricks. Looks like the data's now copied over. Took about 12 minutes in total. This big boy here was nearly 6 gigs. Although actually we only wrote 1.6, and I would imagine this is probably the posts table. So let's have a quick look at what we've got here now. Go up to our DBO tables. Let's look at posts. Yeah, 1.57. Yeah, so that's probably the biggest table that's here. So that's great. So we've now got all of our data in our bronze layer separated out into separate folders. Like I said, you might be wondering why we've got folders here, but that will come apparent as we start getting into Databricks. One thing before we move on to Databricks is don't forget to publish your pipeline. If you forget to publish your pipeline and you log out, or your browser crashes, or your laptop crashes, this work will be gone. You'll only make that mistake once. So publish your changes. I suppose the difficulty with publishing changes is you have to make sure that the activities are set up. So for example, if I came in here and I did the source and wanted to publish, I can't, because it needs to have a sync in order for it to work. And so it will complain and say you can't publish unless the sync's there. Okay, great. So the next part of this, we're going to be looking at Databricks, which is where we're going to transform our layers from bronze to silver to gold. Okay, let's head over to Azure and let's have a look at all of our resources. So what we want to do now is we want to go into Databricks and we want to transform our bronze layer into our silver layer. But in order to do that, there are some prerequisites. So we need to do some setup to enable that to happen. And you'll see that there's a couple of different resource groups here. And you've got Databricks, RG, DBW. When you set up Databricks, Databricks sets up a few different services in order for it to operate. So if we go into the resource group that Databricks has set up as part of its service, you can see there's a few different things. You've got managed identity, you have some storage, and you've got this what they call a Unity Catalog Access Connector. And the Unity Catalog is new-ish into Databricks. It's a catalog that allows you to have more fine-grained control and governance over your data. But what that means is for us is, whereas before you would normally use something like an access key or something like that to get at your storage, it means that we now need to allow this kind of finer grained access. What we need to do in order for that to happen, we need to go into our storage here. And that connector here really is a way for Unity Bricks to kind of dip into Azure, but have some governance around it. So let's go into our storage and then let's go into our access control here. And what we want to do is we need to allow our Databricks connector access to our storage. So we're going to give, so the role that we want to give it is a storage blob contributor, okay? And it says allowed for read, write, and delete access to Azure, blob, containers, and data. So we're going to click connect, next. And then the managed identity is here. We could allow users, but we're going to give the connector to allow us to do that. So we'll select members, and then it's going to say the managed identity is for what? And we're going to say, well, it's for the access connector for Databricks. And then we're going to select the one that Azure Databricks has created for us. Now we could create this by ourselves. We can spool up our own different catalog connectors, but in October 2024, Databricks does that for us. So we'll select, and we'll do review and assign. Okay, and now what that does is that allows Databricks now to access our storage. So what we need to do is go into Azure Databricks, and we need to launch our Databricks workspace. And that's going to sign us in. So you can see on the left-hand side here, you've got a workspace, and this is where we'll be creating our notebooks with our Python code. And you've got catalogs, and this is the Unity catalog, and this is where you will have that fine-grained control over your data and your tables and volumes. There is a lot that goes on in here, so we're not going to be doing a deep dive into this, but we will be using the external locations to create access to our storage. But for now, if you want to have a go and look that up yourself, then feel free. But what we need to do first of all is we want to go and create some compute. Right now, we don't have anything to run our code on. So we need to be able to create that. Now, the easiest one is there's a button here called create with personal compute. Now you need to bear in mind that, like anything in Azure, if you spool up tons and tons of compute power, then you will pay for it. But hopefully if you're on the now this isn't expensive at all, so don't worry about that. The personal compute, if you look at what we're actually going to spool up, is 4 cores, 14 gigs of memory. It's like 0.75 dBU per hour. It's nothing in comparison to what you could have some of these things in here. So what we're going to do is we're going to spool this up. Now there isn't anything you need to do in here except change the terminate after, and I'm going to put that in as 15 minutes, because what happens is if you don't terminate it, then it will just keep running, and it is compute power that you are actually paying for. And I think the only other thing I need to mention is when you do spool this up, make sure that under the runtime, it does tell you that it's part of Unity Catalog. And the reason for that is because what happens is that I found in the past is sometimes when you create your compute, it doesn't link to a Unity Catalog. and then you're spending hours trying to debug why your notebooks won't run against your storage, and it turns out that's because the compute wasn't assigned to it and therefore doesn't know anything about Unity Catalog. So that's just a tip for you. So we're going to click create here, and that normally takes a few minutes to run. So I'm just going to let that run, and then we'll be back once it's finished running. So our compute has now run, took about 10 minutes to run. Now what we need to do is we need to set up some access to allow things to connect together in our catalog here. So one of the things we first need to do is we need to manage the access that we're allowed in the meta store. The meta store is kind of what drives the catalog here. So I'm going to go into our meta store here, and I'm going to say permissions. And let's see. Okay, it looks like I've got all the permissions I would need, but actually, can I take these off? Okay. So really, not sure why that's given me. Tell you what, let's take these off because we are all about ensuring we can give them only the least amount of access. So what we want to do is we want to create an external location for now, and I think create a storage credential, and I think that's it for now. So let's just give that all users, and that's fine, right? So we just want, because really we're only interested in creating an external location. So an external location is pointing to our different layers. So that would be bronze or silver. And then creating a storage credential. A storage credential is the storage credential that, or the credentials that allows us to access our external location. And so if we go back to our catalog here, I think that should be it in terms of permissions. Let's see, do we need any permissions in here? Create schema, execute. Let's see if we maybe execute. We'll go back to that in a second. We might not need that for now. But let's go back to our catalog, and what we need to do is we want to add an external location. Our external location for this is going to be bronze, and the credential is we are going to create, we've already have a one that's already connected. So if you were going to create this from scratch, for example, if I create a new storage credential in there, it's going to say, what's your Azure managed identity? What you would need to do is you need to go back into Azure, go into all of our resources, get our connector here, because this is obviously what's driving everything, and copy our resource ID, okay? And then in here, we would then paste that into our connector and then put our location in. But as we've already got one set up, and like I said, again, because it's now October 2024, Azure, when Unity Catalog first came out, well, certainly from my experience, none of this was set up for you. You had to do it manually. But gratefully and more conveniently, this is all set up for us, which is great. So we're going to select this manage identity, and then our container is going to be, let's do it down here, abfss / and it's going to be bronze at, and I think we called it, where are we, stmrb. So let's copy that over. .dfs.core.windows.net. Okay, so let's paste that into here. Now what's going to happen is I'm going to click create here, and it should just create the external location without any complaints. So let me click create now. And if everything's set up as we expect it to be, it should just create the external location. Okay, great. Now what we need to do is if we go to browse here, excuse me, you should be able to see the data that we set up. Okay, so that's great. So now that means Databricks now has access to our bronze layer. So I'm going to go to permissions, and what we need to do here is we want to be able to read files, I think, for this one only. We don't need to do visibility to read an object in metadata. I don't think so. Okay, fine. So we're going to grant that to all users, because what we want to do is we want to be able to read that in our notebooks. So let's click grant on there for now. And we always want to be good citizens and ensure that we're only having the access that we absolutely need. Principle of least privilege. And let's go into our workspace and let's create a notebook. Okay, so okay. And what we're going to do is we're going to build this up slowly to ensure everything's working correctly, get a feel for our environment, make sure it's working correctly, and everything's connected as we expect it. So let's very quickly make sure everything's working correctly. So what we're going to build this out in Python. So we want to use dbutils. Actually, before we do that, let's connect to our compute before we do that. So we're going to say dbutils.fs for file system.ls. So we're going to read it. And the path is going to be fs bronze at stmrb001 dot and it's dfs.core.windows.net dbo theory. And let's run that and see if we get anything back. Okay, perfect. So that's great. And what you'll find is normally you would normally have to do quite a lot of setup to allow this to happen. You'd have to kind of create some config at the top here to access keys and things like that. So for example, if we were to do this in terms of config, the way we could do this is we could use the API keys of our storage. So we could use something like this where we're saying spark.conf.set, and then we would point it to our Azure Key and then give it our access key. And if you're wondering where we get that from, basically, if you go into your storage account and under access keys, you'll be able to see your access keys here as well. But we don't need to do that anymore because we've got Unity Catalog, and Unity Catalog is the fine-grained permissions and governance that allows us to have that table kind of level access down to our environments. So we don't need this now. Of course, if you are struggling, let's say your environment's not quite working for you and this whole setup doesn't work, then this would be a very good backup plan. If you wanted to continue, you could just do this. So if you just write this out at the top of your notebook, that should hopefully give you. Now, obviously, your key is going to be different to mine, so you need to go in here, show your key, copy it, and of course, make sure you change the name of your storage location there. So I'm going to delete that. So that is perfect, okay, because that is showing us that we can see everything we need to here. The next thing we're going to do is we're going to try and transform a single table to try and get a feel for what we're doing here. Now we've got a users table that's kind of at the top level here in our environment. So what we're going to do is we're going to create our bronze container, and that's effectively going to be this here. and then we'll paste that in there, wrap that in quotes. And we're going to create our schema, which is going to be DBO. Then we're going to create a bronze path, which is the bronze container plus slash plus the schema. So that would be something like bronze DBO, like that. And then we're going to create the users table so that we can check to make sure that everything works on that side. So we're going to say bronze container. Let's say, yeah, bronze container, because so we're not going to say the bronze path, because if we look at our container, our dbo.usersParquet table is at the top. So we're going to say bronze.container plus slash plus dbo.users.parquet. Okay, and then we're going to read this. We're going to read that data by doing spark.read.parquet, and we're going to call it users table, and then we're going to display that table. So let's run that, and hopefully, oh great, so we're now getting some data back, and this is the users table here. So let's move on to another code block. And what we need to do is we need to be able to get access to the tables, but we need to do that dynamically, because what we want to do is we want to load all of the tables. We want to transform some of them, or the users table, and then we want to load it into our silver layer. So let's start by creating an array of table names, and then we're going to say for I in dbutils.fs.ls bronze path. So what we're doing here is we're trying to get access to the folder structures here, because this is really the table names, but also the tables that sit underneath it. And then from there, we're going to say table name dot append, and I'm going to say I dot name, and we're going to then, well, let's do that first and let's see what we get. So let's print. And then let's down here, let's say table name. Let's see what we get. Right, okay, so that's not quite right, because we need to be able to remove this slash. So we're going to then say, let's split that by that, and then that one there. Okay, so let's run this now. Okay, great. So now we've got a list of our tables. So let's move on to another code block here. And what we're going to try and do is really, we want to try and transform this table, or at least the users table. Let's see if we can first transform the users table. Let's validate what we're doing first of all. So we're going to import a couple of things first. So PySpark.sql.functions import, and we're going to import the regex, because we're going to need that in order to get access to the HTML tags. Regex replace. We need when and column. Okay. From there, we need to then load our table. So we're going to do spark.read.parquet, and we're going to read the users table. And then from there, this is where we're going to transform the data. So we're going to say df.width column, and let's, because we're going to be using it, okay, actually, let's not worry about that for now. So we're going to say about me. So if we go back to SSMS, the column's called about me, and this is what we're going to transform. The column is going to be called about me, and then what we're going to say is we're going to say regex replace, and the column we're replacing is about me. Okay, and this is a shortcut to saying give me the about me column, and the regex is going to be open quote, open bracket. So basically anything in here is going to be replaced. So we're going to say everything in brackets and anything between those two brackets. And we're also going to say replace everything with a new line character. And we're going to replace that with a blank. Okay. And let's see if we display the let's see what we get when we run this. So again, what we're trying to do here is we just want to try and build this up very slowly, so that we're not so that we don't miss anything out. Excuse me. And clearly that hasn't quite worked because our regex is not quite right, because we need to say anything with inside. So let's try and run that again. Okay, perfect. So now if we look at the data, we've got the about here, and what we want to do is we want to remove these. We've removed the HTML tags, but what we haven't done is we haven't removed the spaces yet. So let's do that, and we're going to say dot width. So let's make this look a bit nicer. Width column. Let's say width column about me, and within here we're going to say when the column is about me equals nothing. So if it's blank, then we're going to replace it with a null, which is none in other words. And then otherwise, we are just going to say give us the column without transforming it. Okay. And then let's run. Okay, perfect. So all of these nulls here, where it's blank, they're all nulls now instead of being characters. So that's transforming the data slightly. Now, the other thing which I don't like about this table is if you look, the age and the email hash are blank, right? They're nulls. There's no data in them. And also, I'm not a fan of storing things like age. For performance purposes, it's probably they probably did that instead of calculating on the fly the age. But things like age, downvotes, things like that. I think anything that can be calculated shouldn't really be stored, as a hard value. I mean, age is very simple, and we really shouldn't be storing that here, I don't think. So we're going to drop those columns. So let's go back to our table, to our code here, and we're going to say drop, which is fairly simple, age, and we're going to say drop email hash. Oops, I'm a bit awry there. Email hash. Okay, I'm going to run a new line. Let's run that. Okay, great. So age is gone and email hash is now gone. Okay, perfect. Now, okay, what we want to do is we want to start bringing this all together to then transform. Now, bear in mind that we've built this up very, very slowly, just so that we can validate what we're doing, make sure we're not doing anything silly, making sure the parser correct, the regex is correct, dropping the right columns, things like that. We're just confirming what we're doing, because bear in mind, this is going to be part of a bigger pipeline that's going to run, which is going to run every time a new role comes into our data, etc. So we need to make sure that we're validating what we're doing. So let's create our final notebook here. And this is where we're going to do everything in one go. And the reason for that is because what I will eventually do is I will remove all of this at the top. We'll take all of this stuff out and we'll just have it in our final container. So I think let's take a copy of this. Let's take a copy of this into our final notebook here. And we are going to import our functions that we need. So PySpark.sql.functions, import regex, replace, and we need when, and we need column. So we have our bronze container, which we're going to access our data for, and then we're also going to need our silver container. So let's add that one, and that is going to be the same as our bronze, except it's now silver. stmrb001.dfs.core.windows.net. And we've already defined our schema, so we need a silver path, which is going to be the silver container plus a slash and then plus the schema. So that's going to be something like silver DBO and bronze DBO, like that. Now we haven't set up our silver external location yet, so let's go back to our catalog and let's set that up. So let's go and create our external location. Create external location. This one's going to be silver. Same storage credential, and then in here is going to be abfss, and it's going to be silver at stmrb001.dfs.core.windows.net slash. Hopefully I've entered that correctly. Perfect. Again, we're going to read but also write this time, because we need to write to our silver layer. And again, we don't want to say all privileges. We're just going to say, just grant us the least amount we need for our job. Click grant and go back to our workspace, into our shared notebook. And actually, while I'm here, I'm going to call this bronze to silver. Okay. Transformation. Great. And then down here in our final notebook, we're going to start transforming the data. So let's define a function called clean column. And we're going to give it a data frame and a column. And effectively, this is going to be what we wrote up here. So let's paste that. I would never advise copying and pasting code without understanding what it does, but as we wrote it, and I think what we can do is we can change all occurrences here or to be column. Okay, great. And then we need to make sure we don't forget to return our data frame. So that's with all the changes that we've just built. Why is it causing me a problem? Because I've spelled column wrong. Okay. The next part is we need our table name. We'll say for I in db utils.fs.ls, and it's going to be in the bronze path. I'm going to say table name.append. That's going to be i.name.split. Take the first occurrence. And then this is where we're actually going to start doing the transformation. So we are going to say I in table name. The path is going to be the bronze path. plus a slash plus the table name, because that's really the folder, then another slash, and then the file. So that's going to be .parquet. Okay, so really that looks something like bronze dbo users and then users.parquet. Okay, once we've got that, we're going to load our data frame. So we're going to say data frame equals spark dot read parquet, and we're going to read the path. Then once we've got that, we need to check if we're on the users table. So we're going to say if I equals users, and you could probably change this to be a variable so that we're not hard coding in, but that's fine for our purposes here. We're going to say we're going to clean the column and we're going to give it our data frame, and our column is going to be about me, and then we're going to say drop, and we're going to say the age column and the email hash. I think it's called. Now, once we've transformed our data, we need to write it to our silver layer, but we're not going to use the Parquet format. We're going to use the Delta format, and the Delta format is Databricks open source format, and it's pretty much exactly what it says on the tin. It allows you to store the deltas of the data changes, so it's pretty much it's it's built upon Parquet. It's got all the benefits of Parquet, but has some extra features like being able to track history and things like that. So we're going to create an output path, and that's going to be the silver path plus our slash plus our table name or folder name, if you like, plus slash. So that now gives us silver DBO, because we've got in our silver path, we've got our schema, and then it's going to be users, and then it's going to be, and then we're going to write our data. So the actual, we're going to print the path actually, so that we know what we're working on at the time. And then what we're going to say is df.write.format, and the format's going to be delta, and then the mode is going to be overwrite, and then we're going to save that to our output path. Okay, and that's it. That's our transformation from our bronze layer to our silver layer, and it's complaining here. Why is it complaining? Invalid syntax for I in table name. Okay, that should be okay. Great. Okay, let's click go. Oh, start and attach and run. Okay, so it's been a while since we actually ran this, so it's going to spool up. Okay, we'll give that a minute and we'll be back. Okay, so our cluster is now reconnected and we've got a failure. So let's see what's happened. We're saying our path is incorrect, and that is because what it should be is I. Because you've got the table name, so let's run that again. Let's see. And that's why it's important to try and build this up, so you've got a clear understanding of how the transformation is going to work. There's no point trying to come in here and write hundreds of lines of code without slowly building up and testing it. Now let's see what's happening. We're starting to build up some jobs here. We're on badges. Okay, hopefully. Now let's go over to our silver layer. Let's refresh this. Okay, so we've got DBO here, got badges. Okay, and this is what it looks like in terms of the Delta format. So there's lots of metadata about this data in here. So you've got a Delta log in here, shows you kind of the changes, and there's lots of JSON in here. I don't think we can view this here. You can download it, but and that's the sort of power of the Delta format, because it really allows you to explore the history of the data and the changes, etc. Now, let's see. Okay, so we spooled up quite a number of jobs here to help us chunk through this data. And this is where the power of Databricks come through. Obviously, if I had something a bit more powerful in terms of a personal compute cluster, it would have blazed through this already by now. But while we're waiting for that, okay, so users has been transformed as well. So that's great without any issues. So let's go back here. Let's see. Obviously, we won't be able to see the transformation that we've done here. That's good. Perfect. So that's now complete, and we've transformed our data from our bronze layer to our silver layer. So the next transformation that we want to do is silver to gold. The final transformation we want to do is transform our silver data into our bronze layer. So let's head back into SQL Server Management Studio. And as you can see, the Stack Overflow data, it's in pretty good shape, to be fair. There's not a lot of transformation that needs to happen here, but we're going to create a scenario. So we're going to say, select the top 100 from, from users, and then select top 100 star from posts. Let's put star there, run this. As you can see, there's lots of different dates in our table. So you've got creation date, last activity, last edit, last access date. And the business have said, actually, these shouldn't be timestamps. The column says it's a date. It should just be a date. The time is irrelevant, and they're changing the application so that it's only ever going to put in a date in here. So let's take that and run with it in Databricks. We're going to go back into Databricks and slowly build up our queries like we did from our bronze to silver layer. Before we do that, we need access to our gold layer. So let's head back into our catalog, and then let's go into external data, and let's create an external location. So this one is going to be called gold. The storage credential has already been created, and we've already given that access. So we're going to use that one. A URL is going to be abfss :// and it's going to be gold at. So let's do this down here so you can see what I'm typing out. Gold. So that's the container name. That, and then it's at, and then the storage account. So our storage account is stmrb001, and then it's dfs.core.windows.net. Okay, so we'll paste that into there, and let's create. Okay, now that that's been created, let's grant our permissions. And like I said, we really need to be good citizens here and only grant what we absolutely need. So we need read and we need write. Don't need these other things here. We're not creating volumes or tables from it. But just a point on that, what you can do is you can create tables over our gold layer. Now, We don't need to do that in this scenario because there's no reason why we couldn't, but we don't need to do that in this scenario because we aren't doing any analytics here. It's just straight transformation. We're not browsing the data or finding out any analysis on the data. So we don't need to create the tables. We don't need to create external volumes or manage storage. So we're just going to say we need read and write. I'm going to say grant. Okay, so now if we go back into our external relations, we've got bronze, silver, and gold. Okay, let's head back into our workspace. Then let's click workspace and then into shared and create a new notebook. And this is going to be called silver to gold transformation. Let's start by checking that we've got access to our container. So let's do silver container equals abfss, and then it's silver at stmrb001.dfs.core.windows.net. Then our schema equals dbl, and then our path is going to be our silver container and then our schema. Now let's just check. Let's pull back our users table. And our users table is going to be our silver path and then users. So in theory, we should be able to say df.spark.read.format. Format's going to be delta, and we're going to load the users table, and then let's display that. Okay, perfect. And you can see that the creation date here and the last access date, they're timestamped, so we want to modify those. So let's start building this up. Let's go up to here and then let's import some functions. So we want to do pyspark.sql.functions, and then we want to say import to date and lower. Okay, and the lower will become apparent in a second. Now what we want to do is we want to iterate over the columns of our user table just so that we can check if there's a date, and if there is, then we can modify it. So let's do columns equals df.columns, and then we can say for column in columns, and then after that we can say if the date is in the column but a lowered version, a lowercase version of it, then what we want to do is we want to transform that date. So we're going to say df.width column, and that's the column. We say to date, and then we say df.column, because what we're doing is we're pulling out that specific column in our array of columns from our data frame, and then we're going to modify it to be in standard kind of ISO format, if you like. Okay, and then hopefully once that's run through, we should get a nicely formatted date in each of these columns. So let's run that now. Okay, so we've got, that was what it was previously, and this is what it is now. Okay, perfect. Okay, great. So now let's modify this so that we are going to pull everything in. So let's write it out in its entirety. So what we want to do is, again, we're going to say from pyspark.sql.functions import to date and lower, and then we need our silver container. So let's just borrow this from here. paste that in there. And then now bear in mind that obviously this is just some testing, so we're not actually going to be using this one here. We're going to get rid of it eventually, and that's not going to be part of the pipeline. So we need somewhere to write this. And what we're going to do is give it the gold container. So our gold container, which is where we're going to write this data, is going to be abfs fss, and it's going to be gold at stmrb001.dfs.core.windows.net. And then we've already got our schema. So our gold path is going to be it's going to be our gold container and then plus our schema. Okay. Now we need a list of all of the tables in our container. So to get that, we're going to say table name. This is following pretty much the same sort of logic that we had in our in our bronze to silver. But obviously we're doing some different transformations here. So we're going to say for I in dbutils.fs.ls, and then we're going to pull out our, it's silver, isn't it? Silver path. So once we've got that, then we need to strip out we need to append them in and then strip out the extra slash. So we're going to say append I.name and then .split, and then that's going to split out that and then take the first one. Okay. So now that we've got all of our tables, so let's do table name just to make sure, just to see what we've got here right now. Make sure it's running okay. Great, that's good. So let's keep that there for a second. Actually, get rid of that. Let's get rid of that for now. And then the magic is going to happen in this for loop. So we're going to say for I in table name. I'm going to say the path that we're interested in is the silver path, and then plus I, because we want to pick up the table. So that's going to be something like bronze, it's going to be silver, DBO, and then users or posts, and iterating through. Then we need our data. So that's going to be spark.read.format, and it's going to be delta because our silver data is delta, not Parquet anymore. We're going to load the path. So that's going to give our data frame. We need our columns, which is what we built earlier, but we're going to build it again. And then from here, we're going to say for column in columns. And then if date is in column.lower, this is where we're going to then transform it. So I'm going to say with column and column to date, then df, df column, and then we're going to say y. Bear in mind that is a capital MM. If you put in a smaller m, then well, try it and you'll see. So that is going to give us our data, and then we need an output path. So that should be our gold path /I, and then /. Do we need the /? No, I don't think we do. And then in here, we're going to say print output path, so we know which one we're writing. And then we're going to say df.write and format, which is going to be delta. The mode is going to be overwrite, and then we're going to save it. I'm going to save it to our output path. And actually, I do think we do need that slash. So Okay, perfect. And then let's do display df. Now that's just going to display the last one that we run. So let's kick this off now, and hopefully it should start writing some data. So just to confirm, we've imported some functions. I would always say that it's best to just import the functions that you need. Don't, well, you could import everything. I mean, if you're using hundreds of functions, then maybe there's a case for it. But like select star, you don't really want to do something like import star. Just get the functions you're interested in. Be good developers. Then we're building out our silver container. That's where we're pulling our data from. Our gold container, where we're writing it to. We're trying to understand the tables that we're iterating over. And then from there, we iterate over those tables, pull in the data itself. We then define what the columns are. And then we're checking if the date exists in the column. So quite literally, does date exist in that column name? If it does, then we're going to transform that column, and then we're going to write that output uh, to our output path, which is our gold path here. And then finally, we're just going to display the last one that it runs through, just to make sure it looks okay. So let's run that now. Okay, so we're running badges. We can start in a number of different jobs to help us chunk through that data. Okay, so we're running on posts right now. Posts, I think, is the biggest table in our database, in our source data. So let's go into our gold layer and let's have a look. So just bear in mind that that means going into your all resources, going to your storage, going to container, click on our gold, and then hopefully you should see your schema, and then you should have your tables and then the data that kind of sits underneath it. Okay, perfect. So let's see, let's go back into our data here. So it should be nearly finished. Great, and then this is just showing the last table here, this creation date. Now there are obviously, of course, there are plenty of other transformations you can do in the data. Now this is just very high level showing you some of the transformations. But let me show you something else that we could potentially do. Now, I wouldn't recommend doing this just purely, well, I mean, it's good for learning. But for example, you wouldn't normally do this because you could do this in a view or something. But I just want to show you the kind of power of uh, Python and PySpark in terms of writing transformations of data. So if we go back to SQL Server Management Studio, and we have, you can see here that I've wrote a query, and what we're doing is we're pulling back users against badges, okay? And what that means is you'll see that some users have got certain badges, so they've got teacher, or they've got nice question, student, beta, editor, organizer, and I think that would be some nice data to pull into our users table, or at least we're going to create a table and it's going to be called user badges, which joins that data together. And we're going to do that as a transformation in our notebook. So let's head back into Databricks. And then what we want to do is let's build out a users path, and that's going to be in our silver in our silver path, and that's going to be users. Then we're going to build out badges, and that's going to be silver again, silver path, that's going to be badges. And we're going to create a couple of data frames. So we're going to say the users data frame, and that's going to be spark.read, read.format. That's going to be delta, and then load, and then users path. Okay, and then let's just display that just to make sure that it looks okay. So let's run that. Make sure that that's displaying the user's data. Okay, perfect. Now, bear in mind that this is we're modifying this from the silver path and not the gold path. That's why you still got a timestamp there. And then we want to create a badges df, which is going to be spark.read.format delta load, and then it's going to be this one is going to be badges path. Then let's display badges df again, just to make sure that we're pulling the data back correctly. There we go, easy enough. Then what we're going to do is we're going to join this data. So we're going to say user badges df, and it's going to be, we're going to take the users df and we're going to join that, and then from here we're going to say we're going to join it to the badges data frame. And if you notice, if we go back to SSMS, you can see that the users table is joined on ID, and the badges table, is joined on ID, and the badges table is joined on user ID. That's the foreign key, right? So we need to have a way to tell Python, so PySpark, how to do that. So we're going to say we want to take the users df and we want the ID, okay, and we're going to say we need that to equal the badges df and take the users ID like that. Now there is a third argument here which tells you kind of what type of join you want. So here you could say inner. You don't, when it's just an inner, you don't need that, but let's just keep it in there so it's so you can see it for now. And then once that's done, we need to go down here and then we're going to select our data. Okay, so we're going to say we want users df, and then we're going to list out all of the columns. So in this one, it's going to be ID, and then it's going to be users df, and then about me, and then users df. The other one is age, users df. Then this one's going to be creation date, use df. Going to be display name, and users df. It's going to be down votes. There you go. It's already coming up for us. And the next one is going to be last access date. So really, so we could go through this. There is an option to say select all, but again, you really want to be good citizens and not do select all. It's an anti-pattern, and it will cause you problems eventually, even though it's a nice handy shortcut. So I'm really just writing out the columns of the table here, and then eventually what we're going to do is get down to our so views and then finally it's going to be the last one is website URL. And then finally, we're going to take from our badges, we're going to take name, okay? Because the name is what gives us the actual value of the badge itself. So if we then come down here and we say, let's display the user badges.df, and then let's give this a run. A syntax unmatched error. Where have I done an unmatched? Okay, let's accept that. That's fine. So let's see what it says. That should be user ID, I think. Perfect. Okay, great. So you can see that we've now got our table here, and then you've got your views, and then you've got the name here. Okay, and I think let's write this output to our let's write this output. I think should we? No, let's leave it. The primary purpose of this is just to kind of give you an insight into PySpark and what you can do when you can join data here, and pretty much you can do anything here in SQL, in SQL or SQL Server that you need to. You can do it in PySpark. I just wanted to show you that here. The next step in this is I think we're going to attach this to our pipeline so that this is able to run through as we expect it to. Okay, so now that we've got our two pipelines, so that's our bronze to silver and silver to gold, we need to add that to our data factory. So let's go into our data factory. And what we need to do is we need to give access to our Databricks environment to date so that data factory can access it. And there's a couple of ways we can do this, but for now I'll show you how to do it via access key. But for now, what I want to do is I want to do it via the access control. So we're going to say add role assignment, and then we're going to say privileged administrator roles, and we're going to select contributor. Then we'll select next, and then under managed identity, we'll select members. Then we'll select our Azure Access Connector for Azure Databricks, and then select the Unity Catalog and select, and that's it. So we'll click Review and Assign. And what that allows is that allows our data factory to now access our Databricks environment. So the next part is let's go actually into our Databricks Studio, and we want to attach our Databricks notebooks to our pipeline. So let's launch the studio. And then what we're going to do is we're going to go into manage, and then we're going to say a new service, then going to compute in Azure Databricks, click next. We'll leave the name as that for the moment. Then we'll select subscription 1, and then we'll select our workspace. And then we want to look at an existing interactive cluster because we've already built one. We've already spooled one up, so we're going to use that existing one. Now you can see under authentication type, there's a few different types here. So you've got access token, managed service identity, or user assigned managed identity. So let's select managed identity. And then underneath existing cluster, it's not coming up here for what we need. Now let's try again. Here we go. So then we can see here, now if it doesn't come up for you, just click back to new and then existing, it should come back. So you can see here that I'm able to select that. And that's because of what we did before where we assigned our Databricks access connector to our data factory. But before we carry on, I just want to show you how we could do that via an access token. So let's click access token, and you can see that right now we don't have an access token. So let's go and create that. Let's go back into our, this is just to give you another option on how you can access this if you've got any, run into any problems. So you select our Databricks here, and then we want to go into our settings on the right hand side here. And then under developer, you can say access token. So let's click manage and then generate new access token. And we're going to say Azure Data Factory Access and then click generate. So we're going to copy this and then we're going to go back into our resources and we're going to go into our key vault. Then under secrets, let's create a new secret and we're going to call this Databricks Databricks warehouse, then call it access key. Under secret, we're going to paste that in and select create. Okay. Now, because Data Factory already has access to our key vault, we should, in theory, be able to go into our Data Factory and then under Azure Key Vault, under access token, because we don't want to paste this in here like that because that might change. We might change it another day. We might create a new token or have to revoke it and create a new one. So let's go into Azure Key Vault and then we'll select our key vault and then the secret name is going to be our Databricks warehouse access key. And then in theory, what should happen is our access should spool up to, great. So we can see it there. So this is just to give you another option on how to spool this up and access our compute here. And really, this is just another way of doing it. But while we're here, we might as well use this one. So let's select our compute and then click create. Then if we go into, let's publish that. Don't forget to publish, otherwise you'll lose your access. You'll lose what you're authoring. So let's go into copy all tables. And the service we want is a notebook. So let's now make sure you select the Databricks one, not the Synapse one. And we drag that over into here. And then let's set this up. So this one's going to be bronze to silver. And then under Databricks link service, we're going to select our service. We can check test connection. That seems to be all good. And then under settings, under notebook path, we'll click browse. And hopefully if you've set them under your shared environment, they should be there. So if you click on shared, and what you should see is bronze to silver. So we're going to select that one and click OK. And then we're going to say we want on success, we'll click to our notebook. And then that's our bronze to silver. And then we need our silver to gold. So we select a new notebook and do the same thing. This one's going to be silver to gold. The Databricks is going to be that one. And then our notebook, browse, shared, and silver to gold. And then we're going to on success, we're going to run that. So that's our pipeline. And let's, I think, run this and see if everything works as we expect it. So click debug. And then down here, we can monitor the output. So it's going to run lookup all tables. So that's fine. So it should start kicking off all of the activities that we need. And let's see how long this takes. Okay, so I'm going to speed this up and then we'll come back on the other side when this is finished. So the next part of our project is going to be creating our data warehouse. Our data warehouse is going to be created in Azure Synapse Analytics. So let's head on over to our resources and let's go into Azure Synapse Analytics. Now there isn't any setup here immediately in our warehouse here because when we set this up, we already gave it access to our bronze, to our storage. So what we can do is go directly into our Synapse Analytics Studio. Now, what we're going to try and do here is we're going to try and build out our our data on top of our gold layer. Now, bear in mind that this is a logical layer, so we're not going to be ingesting any data into our warehouse here. We're just going to be sitting the warehouse on top, logically on top of our gold layer. So if we look at our linked status here, we can already see that we've got access to our primary storage, and we can see that we've got our gold, primary, and bronze and silver. So let's see what we've got in here. So if we go into here and we select users, we can do new script and then select top 100 rows. And then we need to tell it that it's in the Delta format. And then we click apply. And then you'll see, and I'll go through this in a second, but if I run that, you'll see that this is going to pull some data back. And this is already using the built-in server that Synapse gives you access to. And it's cheap in terms of it running because it runs on a per terabyte basis. And so we won't be hitting anywhere near that in this project. And hopefully this will come back soon enough. Okay, great. And looking at this, it appears there's a slight bug in our Databricks transformation. So in the about me, you can see, okay, there's no tags in here, and where we had blanks, there are nulls in there, so that's great. Our dates look great, but we should have dropped age and we should have dropped email hash, but they're still here. So let's go back into our pipeline, into our Databricks, and let's see what's going on. So in our workspace, let's open up our workbooks, our notebooks here in shared. Bronze to silver, did we drop it there? Yes, we did. Okay, perfect. So you can see that what we're doing here is we're checking, are we looking at the users table? If we are, then we're going to clean up the columns, and then we're going to drop age and email. That looks fine. What's the issue here? Well, the issue is that the data frame, when you perform an operation on a data frame, it returns a new data frame. So it doesn't change the data frame in place. So what this should have been is df equals, and then that would then replace or drop those effectively. So let's leave that as is for now. And I think what we should do is let's go back to our to our pipeline here, and then let's kick this off again. So I'm going to hit debug, and what it will do is it will run through everything again, and just because we can. So let's kick off our pipeline, and because we've seen a bug and we fixed it, and hopefully it should work out. So let's kick this off. We're going to hit debug here, and then once that's kicked off, that's going to run. Then we can then go back into our Synapse Analytics while that's running, and we can kick off. So just make sure that that has saved. That should have saved. That's fine. Okay, perfect. So let's go back into our, and while that's doing that, we can start to have a look at what we're going to be building out in here. So you can see we're able to access one of the tables here, but what we really need is we need a database to store our logical views. Now, if you go back into workspace here, you can see that there isn't anything in here. So you've got integrate, and that's where you're going to do pipelines, and then you've got develop, and you've got some scripts, and then you've got a workspace. So if we click up the plus button here and click SQL database, you can see that you've got two here. You've got serverless and you've got dedicated. Serverless is, you see, it says here that serverless SQL port is immediately available for your workspace. And if you click learn more, it will take you into some more detail about that. But pretty much that means that there's no storage behind this. Everything that you do in here is logical. And then you've got dedicated, which is pretty much a standard dedicated database as you would, and it's backed by storage. So that would be something akin to SQL Server, for example. So our database here, we're going to call this Stack Overflow, and then we're going to say create. And then once we've got that here, you can see that we've now got a Stack Overflow database. And I think what we want to try and do is we want to try and build out a view on top of our data. Okay. So what does that look like? So that means what we're going to try and do. So let's say, for example, this one here, we're going to say select star. Okay. And we need to change to our database here. And then what we're going to do is we are going to say, we're going to generate a view. So we're going to say create view. And then this is going to be dbo dot, and then we're going to call this, users, okay? And then as. Now, if I run that, that's executed successfully. And if I go in here and select view, let's refresh. So you can see now that I've now got a view. It's just logical, and this sits over on top of our data. So this, excuse me, on top of our, and you can see the difference being is, so for example, what this is doing is this is using the open row set function to pull in delta from our DBO gold users from inside our storage. But if you look at how this pulls the data in, if we say new script select top 100, it's as if the table is sitting in our database, except obviously it's a view and it's not sitting in our table, it's sitting in on a serverless database. So what we need to try and do is we want to create views on top of all of the tables, and we could just go through and create those. That would be simple enough. But let's make this a bit more substantial and a bit more dynamic, and let's create a pipeline to do that for us. So let's go into develop, and then go new, integrate, sorry, go to new and pipeline. And I think we're going to call this pipeline create gold views. Okay. And then what we're going to say is we are going to look at a get metadata activity. And for all intents and purposes, this is a bit like lookup. There are some subtle differences, but this is really going to give us what we need here. So we're going to call this a get all tables. Okay. And in the settings, in the data set, see that there's nothing in there at the moment. We're going to say new, and then we're going to select Azure Data Lake Gen 2. And that's because what we're interested in is getting access to our gold layer to understand what tables we have or the metadata around those tables so that then we can create our views. So we'll click next, the select binary. Doesn't matter what you really select here, just select binary. And then we'll say get all gold tables. And then in here, we're going to select our workspace default storage. And this is the default storage that was added when we first set up our Synapse workspace. And then we're going to browse, go to our gold layer with the DBO. And this is what we're interested in. So we'll click OK. OK again. So now we've got a list of, or we will be getting a list of our tables, but there's another thing that we need to do here, and that's under field list. Because like lookup, you need to tell the get metadata what we're interested in. So we're going to click new, and then under here, we're going to say child items, okay? So if I click on debug here, once that runs, you should hopefully see what we're interested in, which is a list of tables. Here we go. So you see you've got child items. So again, this is very much like lookup in that you've got an output, you've got then a JSON array, and then within that array, you've got some data. Okay. So now that we've got that, we want to build a for each. Okay. And we're going to connect that. We're going to connect that. Okay. And then what we're going to do is we're going to run a stored procedure. So let's go up here. Okay, but what is that stored procedure? Well, what we're going to do is we're going to create that stored procedure now, and hopefully it'll become a bit clearer as to what we're trying to achieve here. So I'm going to go back to where am I? Integrate data and then workspaces. And what we should have in here is our we've got our Stack Overflow database, but we need to create a stored procedure in here to enable us to build out these views dynamically. So let's click new script. It's going to be an empty script. And then we're going to write some dynamic code here. So we're going to say drop procedure if exists. And it's going to be dbo.create stack overflow views. Go. Then we're saying create procedure dbo.create stack overflow views. And this is going to take two arguments. It's going to be two parameters, a schema. It's going to be 128 and a view name, which is going to be a varchar 128. Then from there, I'm going to say begin and then end. Okay. Now, the first thing we need to do is we want to generate some dynamic SQL to, first of all, drop the view if it already exists. So we're going to say declare SQL equals varchar max. We're going to say set SQL equals, and here we're going to say drop view if exists, and then plus schema plus dot and plus view name. Okay, and then we're going to execute that that SQL. And then from there, we're then going to actually create the view. So we're going to say set SQL equals create view and plus schema plus dot plus view name plus and then as. And then down here, we're going to say select star from, and then it's going to be open row set, and then it's going to be bulk. And then we're interested in our storage, which is going to be https //mrb001.dfs.core.windows.net /gold/dbo/ and then we're going to add the view name, and then that's going to be followed by a slash, okay, like that, and then format equals delta, and then we're going to say as result, like that. Oops, result. And then what we're going to do is, in fact, let's do print, and let's do print before we get ahead of ourselves, and just check that our code is working, or is at least printing as we expect it to. So let's run this. Incorrect syntax near the equal sign. So where have we gone wrong here? SQL. Okay, so there we go. That's the problem. Incorrect syntax near the dot. Okay, so I must be missing a plus. Go run that again. Okay, great. So that's now run. So let's go down here and let's see if we can execute this. Create stack. It's not coming up. So create stack overflow views, and then we're interested in schema is going to be DBO, and then the view name is going to be, let's call it users. Okay, and then let's run that and see what we printed. So we're going to say drop view if exists dbo.users, and then after that we're going to create a view, select star from open row set bulk format equals delta as result. Okay, that looks good to me. So let's see if we can run this. Let's see if we can run this now. Let's run that, and let's run this, and let's see. It's doing something. Okay, perfect. So it seems to have run. So if we refresh this, there we go. So our view's still there. So it's obviously dropped it and created it. So what we're going to do is we are going to use this stored procedure now to generate those views. Now, before we do that, let's go back into our pipeline. Data, here's our pipeline, create gold views. And now we've got our stored procedure here. Now our link service is, we're going to create a brand new one. So we're going to say we need a new linked service. And in here, this is going to be our SQL, let's do stack serverless, serverless stack overflow, and then and then down here it's going to be an Azure SQL database, and then we're going to enter manually here, and underneath we're going to, in order to fill this in, because don't forget we're running this against our database that we created here, against our Stack Overflow. So what we need to do is we need to go back to our workspace or back into Azure here, and then under Overview, under Synapse Analytics, under Overview, we see that there's a serverless SQL point. So we need to copy that, then go back into our workspace and paste that in there, and the database is going to be Stack Overflow. Okay. And then in terms of authentication, we're going to use system managed or system assigned managed identity. So that's already built in. So we'll select test, and hopefully that should connect directly to our database and our serverless server. It's taking a little while. Okay, great. So it's connected successfully. So we say create, and hopefully what should happen here is our stored procedure should pop up any minute. Refresh. Taking a little while to pop up. Here we go. So we've got our create stack overflow views. And then down here you can see that there's a very handy button called import, and you can import the parameters. So the value of our schema, that's going to be hard coded in because we're just going to call that DBO for now. And then under the value, obviously the view name, we need to add that as dynamic content. So we're going to say add the content, and then under here you can see, and then we're going to call it name, okay? Because that's what, if you remember back to the output, it was called the folder name was called name. So that's fairly simple. So click OK, and that should, in theory, be it. So we should be able to click debug here, and it should go off, and for each one of those folders create a view. So let's click debug. Okay, and it's saying that there's an item required. Okay, so the items that are required, like our get like our lookup, you've got all these different types here. So we want the child items here. Okay, and that's the only thing that you need to remember to put that into here. So I'd forgotten that, but because if you remember back, if you looked at the payload, it was output and then child items, and then obviously, so we select OK on there, and then obviously in our stored procedure, we're saying the item dot name, which is underneath the output dot child items. So let's click debug, and that should kick off. Hopefully they should all run in parallel. So that's getting the metadata now. Great. So we're starting to kick off each of these now. So let's see. And hopefully they should start to appear immediately. Great. So don't forget to publish your changes when you create your assets here, because otherwise if you forget and you go away, you come back, they may be gone. So let's go back into our data, and in our workspace, let's refresh our views, and hopefully, great. So this is where we should see all of our data now. Let's check to see if our pipeline bug fix worked. So let's say select top 100 rows and click run. Interestingly, it is still there. Okay. I wonder what happened to the, so let's see if we can see what exactly happened here. Okay, so that was just, we took it from the silver, so that should have been okay. So let's see. Bronze to, yeah, so let's do bronze to silver. Okay, so I can see where the issue is. So what we're doing here is, yes, this is correct. So what we're doing is we are dropping age and email, and then the returned data frame will actually drop those. What you need to be aware of is, because of the nature of the Delta format, it doesn't automatically, even though it records the change, it doesn't automatically update the schema. So what we need to do is down here is, what we're going to do is we're going to add, actually we can't do it here, we need to go back to our workspace, go into our shared, and then go to bronze to silver. And what we're going to do is we are going to change this to say, we need an option that is going to overwrite schema, and we're going to say true, like that. Okay, and then what that should do is that will overwrite the schema with the changes that we've told it to. So let's kick that off. So that will then update our silver container. Actually, let's do that. And then what we can do is let's create a new one down here. Let's see. So silver container, that would be dbo.users, and then we're going to say data frame equals spark.read.format delta load silver container, and then if we do display df. So let's wait for that to run through. And this is just typical of when you're building out complex pipelines and working with different types of data and cleaning and transformation. These things are bound to happen, and it's good that you've been able to see something that's gone wrong and we've been able to fix it. Well, hopefully fixed it. We'll just wait for it. So it's written the users table, or it's just about to write the users table. There we go. So let's run this. Hopefully this should be able to run, and we should see that it's now displaying without. It's probably got stuck. Okay, great. Okay, perfect. So that's now disappeared. So what we should be able to do is, let's go through, and we're going to rerun this pipeline from end to end anyway. But what we need to do is we now need to pull that data from silver into gold, because otherwise what's going to happen is our pipeline. So we could go into here and we could run this from end to end. But that'll take a little while. So let's go back into our silver to gold. Let's kick that off. And what this is going to do is this is going to copy our new formatted schema and overwrite into our gold layer. Now I think what we may need to do is we may need to rerun our gold views pipeline. And the reason for that is because obviously those columns no longer exist in the format. So that's age and the email hash. They no longer exist. So we probably need to give those a quick refresh. But let's wait until this is finished to our gold layer. And you'll tend to find these things as you start working through. The more complex your pipelines, the more complex the transformation, the more likelihood there is that bugs will be introduced. I mean, I've obviously gone through this project once before and I've forgot that already. I missed it out, and so therefore it's very easy done. Just these subtle little things that can catch you out, and sometimes you can spend a few hours working through these small bugs, whether it's a data type issue or it's a null environment or you've forgotten to overwrite the schema. Okay, great. So that's now finished. So let's go back into our pipeline on Synapse and let's rerun that. Okay, so that's rerun. Then let's go back into our data, refresh our views, which no longer exist. So there we go. Just took a minute to spool up. So let's do select top 100. Now that is interesting. And the reason for this, okay, so what would normally have happened is because of the fact that we have gone from our from our bronze to silver and we've updated it. So if we go back to recents and then go into bronze to silver, you can see that we've overwritten it. But what we haven't done now, what would have normally have happened is this option would have normally have been on from the kind of get-go. And then therefore, by the time it got to the gold layer, it would have already have been overwritten and you wouldn't have needed to include this. But because of the fact that our delta in our gold layer doesn't know that the schema has now been changed, we need to include this option in there as well. Okay, so let's go back to our silver and gold, and in our overwrite, let's include this here. And hopefully that makes sense, because once the data's been copied from our silver into our gold, it doesn't know anything about the schema's change, because as far as the delta format's concerned, it's recorded it, but it hasn't overwritten it. So it's recorded it, but it's not there for us to consume yet. So let's rerun this again. And that shouldn't hopefully take too long to run. And again, these are just these subtle little things that you need to be aware of when you're building out these pipelines to make sure that you're kind of thinking about the pipeline end to end. So we've fixed the bug in one place, but actually that bug is still propagated up. It's not a bug; it's just the nature of the delta format. But in effect, it's a bug because it's not doing what we expect it to do. Because any other format, Parquet, would have just overwritten the schema. But because the nature of the Delta format is it records the changes, what it's doing is it's recording the changing, but not actually showing you that change in terms of the schema. So we're now saying when we write from bronze to silver, make sure that any schema changes are reflected in the Delta format, and then we need to propagate that up into our gold layer. So this should be done any second now. 43 jobs spooled up in parallel to help us chunk through all this data. And again, if we had a bigger compute here, then this would have been done in a matter of seconds. But obviously, we want to keep the cost as low as possible for us. There we go, that's finished now. So let's go back to our Synapse pipeline. Let's go back to our, let's not publish that a second. Let's go back to our pipeline. Let's rerun it. And hopefully this makes sense while we're rerunning this. If you imagine if you created a view on your normal SQL Server database, We then come along and removed a couple of columns. If you did a select star from that, it would fail because you haven't refreshed the view to reflect the new columns, even though these ones should really, in theory, be okay because we're kind of doing the select star thing, but we're doing that just out of pure speed rather than anything. I would never in production or any other environment do that. You should never select star. It's a pretty bad practice. So let's see if our new table or our refresh table has now disappeared. Great. So that's now disappeared. So we've now cleaned up our data from end to end. We've fixed a couple of bugs that were there. And so the next part of this project is going to be integrating this into our reporting suite. Now, don't forget, let's clean this up. So we're going to let's call this one our create stack overflow views. And we can keep that. This one can go. So we get rid of that. We'll get rid of this one because we don't need these. Get rid of this one and get rid of this one. We did a lot of select stars, so let's get rid of all of these. Script one we can get rid of. Keep that pipeline and then publish, and all should be well. Again, please don't forget to publish your pipelines because they will disappear if you log out. Okay, so the next part of this project will be Power BI. So now that we've got our data warehouse sitting on top of our gold layer, it's time to start allowing the business to view the actionable insights. So the report that's ultimately going to drive some action. And the easiest way to do that, or the best way to do that from a Azure perspective and Microsoft perspective, is to wrap this in Power BI. And that will allow the business users to get access to this data in a visual way, and they can utilize some pre-canned reports, so reports that have already been built, or you can give them access to the model itself and they can go ahead and build those reports. I mean, in that instance, you'd have to ensure that they have some domain knowledge, and that because if you don't have some of that data, you can double count numbers and things like that. So you just have to be careful. But for the most part, we're going to build out a report. And so, having said that, let's fire up Power BI. And let's wait for that to run. This is the October update, I believe, and with dark mode enabled. So the first thing we want to do before we go into the report itself, I want to go into options and settings, go into options, and then under here, under data load in current file, we want to turn off update or delete relationships when refreshing data. And then we want to auto detect new relationships. We want to switch that off. Now, the reason we're doing that is because Power BI wants to try and be helpful. And if you have a model that is perfect and the primary and foreign keys all align correctly and it's nice and beautiful, then that is perfect because once Power BI imports it, it will be able to automatically detect those relationships. But in the real world, in the data engineering world, the world that you and I live in, where data is not so cleansed and friendly and sparkly, we don't have that luxury. And so in this instance, what would happen is we would click this auto detect, we would import the data. If you've got two columns called ID, it will connect them and you'll see in a minute that that's not the case. So turn that off before, otherwise you'll have to go in and you have to check the relationships yourself and make sure that they work, or you may forget about something or think that they're working and it's not, and it's giving you bad data. So let's click OK. And this is Power BI. And if you've never used Power BI, it's a great tool. It's very easy to learn, but also very powerful if you've never used it. And it is kind of drag and drop for the most part, but you can also get under the hood and start creating some really powerful data. But for this is a data engineering course, so this is really about data and not the actual reporting side of it. This isn't about Power BI and how to design these reports. So we're going to create something very, very simple. And the reason for that is because that will allow you, if you would need to go off and design your own reports, and also, we want to ensure that you have the tools necessary to drive your end-to-end pipeline, because this is really the end of the pipeline. This is the end of the road for the data, because this is where your end users will then start pulling on this data to drive the business. So let's start getting at this data. And up here on the top left hand side, there's a get data button. Click that and click more. Under Azure, we want to click on Azure Synapse Analytics. Click connect. And then on the server, what we need to do is we need to go into our Synapse Analytics resource under Power BI, and in under Overview up here, you click on Serverless SQL Endpoint, click Copy to Clipboard, go here, Server, and under Database, we're going to say Stackoverflow, and then you can see that you've got data connectivity mode. You've got import and you've got direct query. Import means it's going to import the data directly into the model. And that has its trade-offs and also its benefits, because it means that you've got accessibility to the data straight away. There's no waiting time. The only wait time you've got is basically the compute power and how complex your queries are. But there are some downsides. So it means that the data isn't refreshed as often. For example, generally speaking, it might be overnight or intraday, once or twice a day. And then you've got direct query, which means that it's up to date as soon as the data lands, which is the one we're going to be using today, because we need this data ASAP, and we need it as soon as it lands from our pipeline. And we'll go through that once we import it. So if we click OK, bear in mind that I've already signed in here, so it might pop up with a screen to say sign into your Azure account. So if you just sign in to your normal Azure account, and that will give you access, because obviously you are an admin and you have necessary privileges to allow that to happen. So what we want to do now is click on all of these tables here and then click load. And what's going to happen with that is it's going to go off to Azure. You can see it's detecting the table schemas. It's trying to understand the metadata around the tables and schemas. And then what it's going to do is it's going to import those schemas and tables into Power BI. And once that's imported, and if you click on the model view, you'll now see that all of the views that we've created have been imported, and there are no relationships right now. So what does that mean? Well, in this data, if we went and tried to create a new report, we wouldn't be able to say something like users and the number of posts they have, because there's no relationship between the tables. So we need to create those, we need to define those. So let's pull our users table down here, and then let's put our post tables next to it. And you can see that they've got different columns in here. So user ID or users has an ID column. And then hopefully in the post table, we should see there is an ID column. Okay, but that's not quite right, because that's the ID of the post, not the user. So what we're really looking for is the foreign key in here, which should say something like owner user ID. And that makes sense because a user owns a post. Okay. And so what we're going to do is we're going to create a relationship from ID to, oops, I all selected, that's why. So ID to our owner user ID. And when you define your relationships, you'll get this dialog here, which is helpful. It's trying to give you some clues about what you've done and ensure that it's correct. So for example, we can see ID to owner user ID. Cardinality is one to many. One to many means that I am a single user and I can have many posts. And you've got obviously different cardinalities. You've got many to one, which is the opposite way, and then one to one and many to many. Okay. We can have a look online for tutorials about what each of these mean. They're not complicated, but they can trip you up. But it's good to understand the relationship between the data, because immediately I know, okay, so I am a single user and I have many posts. Okay, so I'm expecting that there will be more or one or more posts against a user. So it's good to understand, and that's the domain knowledge that you have. So being a data engineer isn't just about wrangling tools and understanding different tooling, Azure, data factories, things like that. It's also being able to understand or have a bit of domain knowledge to ensure that what you're building is correct. We're not just blindly passing data through and hoping it's correct or it works. So let's click save. Okay, and that creates a nice relationship between the two. There's another way we could do this. So if you go up to manage relationships, this is kind of the sort of relationship builder and viewer here, if you like. So for example, let's have a look at what relationships we can have here. So what about users and their comments? Okay, so if I go into new relationship and the table is users and the ID is ID, and if I select comments, okay, now the interesting thing here is, as you can see, and this is what I was alluding to earlier about auto detecting relationships, you can see here that the user table has an ID, which is the user ID. The comments table also has an ID, but that is the ID of the comment. Okay, that is an identity column. It is incremented when a new column is added, and it has nothing to do with the ID of a user. That would be this column. And so if you left that auto detect on, Power BI would have automatically connected those two. And had you not spotted that, that could cause you real issues. The reason for that is because in a lot of instances you may get lucky and have an ID of one and a comment one, but they would have no relationship at all, because the ID of comment one or the owner of comment one could be 490,784. So that's why you just have to be careful, and this is why it's important not to just understand the tools. You should also understand the data. So we're going to say user ID here, because that is what it should be. That is the foreign key of the users table, and it's a one-to-many. Does that make sense? Okay, well, let's see. A user can have one or more comments, and that's right, it could be. So we're going to say that's correct, and we're going to save that. And then you can see, so you've got two relationships now, and I'll drag that down. And I think the last one we're going to do is badges here. So let's just do, you can see foreign key to there. So you've got badges to ID, cardinality should be many to one. Yeah, it's the other way around. Yeah. And that's just purely because the only reason why it's flipped is just because I've changed. I went from badges to the users table, but the cardinality is exactly the same. It's so if you read this, it could be many badges can belong to a single user, or to put it another way, a user has many badges or can have many badges. So we'll select save. Okay, so let's go ahead and now we're going to leave these because we don't need to worry about these for now. This is enough to build out. In fact, the users and posts was enough, but we're going to build out a report. So we're going to go in here and let's build out a very simple chart of the top 10 users in Stack Overflow at this point in time. Okay, so let's create a bar chart. And in this bar chart, we need some data. So we need the display name of the user. And that's going to give us the display name. Now imagine that there are a few thousand people in Stack Overflow database. So this isn't going to be very good in terms of data. But what we're going to do is we're going to put who's posting what. Now, we're going to assume that an ID represents a single post, okay? So what does that mean? It means, let's say I create a post on Stack Overflow asking a question about Azure. My ID is number one. I insert, so in the back end, it's inserted a new post with a new ID of number one, because that's just the first post. And then I ask another one about Power BI, and that's ID 2. So I now have two posts. So let's bring that in now. And that's our many. Okay, that's showing that a person can have many posts. All right. So let's see. Okay, right. So we can see here that there's some weirdness happening here with this blank. And again, this is part of understanding the tooling and also understanding the domain, so the knowledge of the data. So we could build this out and we could hand this off to the business, but then they'll say, well, what does this mean? What's blank? No. And really, we should either have enough knowledge to understand what that is, or if we don't, we need to investigate it. Because I would be very happy to understand, well, why do we have a blank here? Is that just erroneous data, or was there, are there people in Stack Overflow who can have a blank display name, for example? So this is just trying to think about these things and trying to make sense of it. So now that we've done that, let's filter this data out a little bit so that we can get rid of that for now. So let's put the ID on here. And then let's do basic filtering. Not sure why that doesn't come up with options. I have to select them. So let's do basic filtering, and we're going to take out these once that comes back. Now bear in mind, this is obviously going off to Azure, pulling on the data, and then displaying it here. So just wait for that, give that a second. Actually, is this not the posts actually, is it? Ah, yeah. So if we don't, I was just wondering why that took a little longer to come back than I thought it would. So that's not what we want to do. We don't need the post ID. It's the user ID we need. And the reason for that is because what we want to do is we want to take out these blanks here. Okay. So what we're going to do is we're going to say we want everything apart from the -1 and the blank. Okay. Now the reason why I'm coming here at an ID level is because if it so happened that if it so happens that a user can have a blank ID, and that is legitimate for the domain. So users don't necessarily need to have a display name, then I think going in at a display name, so coming in here and then saying remove the blanks isn't the right thing to do, because you're kind of hiding data that is natural in the system and is allowed. Okay. But the reason why I've come in an ID is because you would expect that the blanks, so the people that have a display name that's blank, would have a natural ID, a normal ID. Whereas when I look at this, I can see where there's a -1 and there's a blank. And so to me, that would be strange. That doesn't ring true to me, because I know that this would be an identity column in data. And so you shouldn't be having these weird values in here. And so we've taken it out. Okay, that's what we've done. So we've taken those and we've filtered it out. Now, the other thing here is, well, this is all great, but there are thousands and thousands and thousands. No one is going to scroll through this chart looking for anything like that. Okay, so what I think would be a good idea is just to pull in the top 10. So let's go and put the display name in the filter here. And on the filtering, go down to here, top N. And we're going to say top 10. And this, you see where it says by value? And the value is going to be by posts. Okay. And then we'll apply that. And what should happen in theory is it should remove these thousands of users. So it's still whirring away here. And that's it. You can see that now we've only got the top 10 here. Okay. John Skeet, very well known author. Craver, Alex Martelli. Okay. So and that's it for that chart. So and that would be okay, great. So who's top 10 users? Now obviously this is just very simple. I'm just bringing you through Power BI as a journey. And that could be very valid. People might want to see that at some point. But for now, one thing that I think is a bit more interesting is the total number of users. So if we go in and click a card here, and then what we want to do is we need to bring the ID of users into this visual here. And there's 299.40K, okay? And that looks all great, but actually it's the granularity is not enough for me. I need to go a little bit lower than that. So what I want to do is I want to go into not data format. Yes, so in the call out values under visual, you want to go into display units and select none. Okay, and that's going to give you your actual values. Okay, and then category label that is on, but we're going to switch that off. Actually, why can I not change? Okay, I probably could if I go into here. Well, anyway, I think so. We've turned off the nulls, and I think that okay. So this one is going to be users, and it still says count the ID. I thought that would have been. That's fine. But let's put a title on, and let's call this users. Let's center it down, make it bold, make it a bit bigger. Go. Subtitles? No, we don't want a subtitle. Okay, and we'll just bring that up a little bit. All right, cool. So we've got 299,399, and that's our total number of users in Stack Overflow. Now, what we want to do now is we want to test that our pipeline works as we expect it to. And the only way we're really going to test that is to ensure that our pipeline runs as expected. So I'm going to go into SQL Server Management Studio. And what I want to do is create a brand new user. Okay. So the reason we want to do that is because we want to show that our pipeline is working as expected. So the way we're going to do that is we are going to say insert into, and then we're going to say users, the users table. And in here, in about me, I'm going to put Azure developer. And then age is going to be 41. Creation date, display name, we're going to say Michael. Downvotes, email hash null, that's fine because we've already gotten rid of that. Get date, location is, let's say, United Kingdom. And then reputation, upvote views. And let's see, upvotes views, fine. Yeah, okay, that's fine. And then what we're going to do is we are going to hit, let's execute that. And then let's see if we can do something here. Let me get, so about me. Now, let's do order by creation date sending. Ah, there I am. And there I am from before. So what we're going to do is I've got my ID here. This is my ID now. Start from users ID equals that one. Okay, great. Now we can. So we've now got our user in here. Let's head off to our data factory and let's pull up our copy all tables. So we've now got some data in our on-premises database and we want to pull it into our pipeline. So what we want to do is let's go in and add a trigger here. Let's do new edit and then click new. And then we're going to call this, let's say, call this nightly. And the type we're going to leave as scheduled, but you've got various other different types. You've got tumbling window, which is over a period of time, and then you've got storage events. So if you landed some data somewhere, it can detect that and kick off. And then you've got custom events, and that could be a custom event. But for now, leave it as scheduled. Start date, that's going to be now, but that's just the start date of when the trigger was created effectively for this instance. And for us, time zone, make sure this is in the correct time zone. If it's not, then this won't trigger as you expect it to. So the recurrence is going to be every 1 and day here. On the times, you can see that they must be in the range 0 to 23 for the hours and 0 to 59 for minutes. So this is going to be 23 because it's 23:36. And we're going to call this 23:37 for now, 37. That might change if it flicks on. We're not going to specify end date here for this one. And also ensure that where it says start trigger, that is ticked. Start trigger does not mean when you click OK, it will start the trigger. It means it is effectively enabled rather than starting. So that's fine. And then click OK. Actually, I might change this. Let's do 30. 8. Okay, yeah, because it was just about to change. So we click 38, click OK, and it says make sure to publish for trigger to be activated after clicking OK. So that's important. Make sure you publish. So click OK, and then let's publish this now. Okay, publish. Okay. And while we're waiting for that to start, what we are hoping to happen here is that our trigger, now obviously the real scenario would be that you've built this pipeline, it's now activated in production in the business, and now what we're waiting for is our nightly trigger, which would be normally 12 a.m., 3 a.m., 6 a.m., something like that. It will then kick off the pipeline and import all of our new users that have happened or that have been created in our data set. So the trigger will then go off, look up the metadata of all the tables, copy the tables up into our bronze layer, and then we've got our 2 notebooks here, which is then going to migrate the data or transform it from bronze to silver, silver to gold. Okay, so it's now 23:38. So let's go to monitor, and then let's see. Lost 24 hours. Here we go. So our build has now started, and you can see that it's kicked off. Okay, and it was kicked off by our trigger, and so this is the 12 a.m. pipeline that's now about to run, or 3 a.m. or 6 a.m. So we're going to let that run, and once that's finished, we'll then check back to our Power BI and see if it's imported the data. Our pipeline's successfully run now. So let's go back to Power BI and let's see if that data has imported. And bear in mind that we don't need to go back into our Synapse analytics because we've built logical views which will automatically pull out the changes in. So before we do that, let's clean these charts up a little bit just to make them look a bit nicer. So if we go into our formatting options, x-axis, we're going to change this to be posts, and then on the y-axis we're going to call that display name, and then I think let's get rid of the title. That's fine. And then on this one we're going to change this, going to data format, and then going to whole number, and then put 1,000 separated. Now what we're expecting to happen here is now that and as you can see, obviously this report hasn't updated yet, and that's because we need to refresh the data. So what I'm expecting to see is that this should increment by 1 because we've now created our brand new user. So if we do refresh, that's going to go connect directly to our Synapse Analytics warehouse, and then going to refresh the data. And all being well, we should increment this with the latest user that we've just added. Perfect. There we go. So let's summarize what we've done here. So we've created our pipeline. We've added a brand new user. We've then executed that pipeline via a trigger. So that would be overnight, for example. And then from there, what we've been able to do is add a new user. So if we go in here and let's add some columns in here. Creation date, display name, and let's pull this data back, see what it looks like. So we can do this down here, that, get all of these different columns into our wait for that to pull this data in. And then we can order this on the creation date. Now, where has my 2008? Let's run that again. There we go. And we can see there's the two new ones that we've added, although I I added it once, then added it again for testing. Now, the interesting thing here is that down here, you can see that there's 299,298, 398, and not 400, which is what should be there. And I'm guessing that's because we have joined this. So let's see, we're not limiting this data on here on the page. It's interesting that we've been able to, okay, that's because it's the count of the ID. Okay, that makes sense now. Okay, let's see what's going on here. Let's change this back. Yeah, so you can see that what's happening is it's just counting this ID at the bottom here. It's added a one to the, so let's actually change this because that shouldn't be a count of ID. That should, so we're going to say we don't want to summarize that. So once that changes, because it's not the count of ID, if we wanted to summarize this correctly and show the number, then what we would probably do is do something like the count of the ID here, and that would give us our 299,400 because that's what we're basing our data on here. So let's let that run. That's just working now. There you go. So what we're saying is that we can now see that it's 299,400 and it's grouped up the data here on the account of ID because there's two, right? There's two of us that we've entered in here. And that's it. That is the project in its entirety. And hopefully that's given you a good understanding of the data from end to end. This is fairly typical in most corporate environments where you've got some on-premises data and they want to move it or they want to migrate it into the cloud. And of course, there are different ways that this could be done. For example, it could be that the warehouse that we built, for example, if I go back into our Synapse analytics here, it could be that under the data, where is it? Where is that gone now? Sorry, not in Synapse Analytics here. So it could be that this is obviously a logical view that sits on top of our gold layer, but it could be that the business have a dedicated SQL Server that this data needs to be transformed and inserted into. And that's obviously completely feasible as well, and probably more likely, to be honest, than not. Before we finish, let's take a quick recap to see what we've accomplished and how far we've come. So this is what we intended to build at the start of this project here. So what have we done? We installed an on-premises SQL Server. We took a cut of the 2010 Stackoverflow database and we ingested that into our on-premises SQL Server. We set up our Azure Data Factory, and in order for Data Factory to connect to our on-premises database, we installed the integration runtime, which contained our keys in order for Data Factory to connect directly to our on-premises. We used the Data Factory to source our data from our on-premises and pull it up into the cloud and store it into our data lake storage. We first stored it in our bronze layer. This is our bronze container that we set up. that's the raw, unchanged data, unprocessed. We then set up an Azure Databricks transformation pipeline to take our bronze raw data, remove a couple of columns. So that was the to transform the about me to remove the tags, the HTML tags, and also remove a couple of columns, the age and the email hash that weren't being used, for example. We then took our silver layer and we transformed that. We transformed the dates that were in each of the tables to be just to be kind of ISO standard without the time, and that transformed that into our gold layer. We then set up our Azure Synapse Analytics serverless SQL database that we then use to create a pipeline to create views over our gold layer, and that's an automated pipeline. So should our gold layer ever change, schema changes, things like that, we have a pipeline to run that through and recreate those views. We then created a Power BI to sit on top of our data warehouse to then display some analytics and some data around the gold layer that we've inserted, so the Stack Overflow data. We ensured that throughout this pipeline that we've tried to ensure that the security and identities are least privileged. So we're only giving the absolutely necessary access to in order for the service and us to perform our role. We then went back into our on-premises database and we created some new data. And from there, we then our pipeline triggered off. We created a new trigger to run as part of our nightly build, which then pulls in our new data from our on-premises database through Azure Data Factory into Databricks, transformed from bronze, silver to gold, eventually landing in our Azure Synapse Analytics. We then opened up Power BI, refreshed the data, and we could see that our brand new row that we inserted into our on-premises database was successfully pulled in all the way through our pipeline into our Power BI report. And again, this is fairly typical in large corporates where we've got some on-premises data that needs migrating into the warehouse. And it could be that what they want to do is they create this on-premises database here that's where it's currently sitting, but they want to completely migrate it off. So this then just becomes like an Azure. It could be an Azure dedicated SQL Server, or it could be something in Synapse Analytics. Just depends on the way the business want to build out their pipeline. So they could completely do away with on-premises and just have a SQL Server in the cloud, a SQL database in there. And so we've been able to transform our data all the way through into Power BI so that we can view some analytics and get the business to start analyzing and creating actionable insights on that data. So hopefully this has given you some good insights into Azure. You've been able to install an on-premises database. You've been able to create some Azure pipelines. You've used Python in Azure Databricks with the new Unity catalog and data connectors. You've used keyvault to store our secrets and identity manage to give least privilege or access to services. We've used Synapse Analytics, and then finally Power BI to display all that data. If you've got any questions, please feel free to reach out. Otherwise, I wish you all the luck in your new engineering career.